Good morning. Wow, a little bit more animated than me, please. I don't have the energy today, so it's all on you guys. Good morning.
Good morning.
Hell yeah, a responsive audience. How y'all feeling?
All right.
Hey, see this guy's energy. You all need to bring that, right? So how about Robert? You give us one like that.
Good morning.
There we go. Robert's energy as well. All right. I think we've all got a good handle on this. How was DConf last night? What did I just say?
Awesome.
There we go. All right. So this is the last day of the DConf proper. We've got hackathon tomorrow, of course. We've got all our lightning talk slots booked. I don't think we have anything else to address at the moment, Razvan. Can you think of anything? No? Anybody else think of anything? Would you like me to say something random for the internet?
Yeah.
Well, give me a suggestion and I'll repeat it.
Random.
Hey?
Random.
Random? Oh, come on. No imagination in this lot. You'll just have to make it up for it. It's one of our overlords, Attila. Programming, metaprogramming, sometimes you just want a 4 each. So, applause.
Thank you.
Take it away.
All right, as the slide says, the whole talk is about how regular programming is much, much better than metaprogramming, and sometimes you just want a 4 each. So why am I even doing this to begin with? Well, once upon a time, Andrew gave a talk at DConf 2018 about reflection using string mixins to actually generate the code and then actually have the code instead of metaprogramming, and that caught my attention. And I had done enough reflection work to want a library to do it because D has awesome reflection capabilities, but using it isn't as easy as it could be. And at the time, my hammer was templates, so this looked like a nail for me to bash it in with. And I ended up writing a library for this, and I did a lot of work trying to wrap things in the work I was doing at Symmetry. And so again, I needed a library to do this, and I used the template-based library to do it because that's what I was used to. And I did write something with strings in it because of Andrew's talk, but it was an afterthought. I didn't really do much with it. And in fact, the string API called into the templates anyway, so many of the advantages would have been lost, especially with regards to compile time. And I ended up trying to finish this so I could do a talk about it here at DConf. So let's do it the proper way. But how do I get to templates anyway? Why did I love them so much? Well, before I wrote D, I start with BASIC and all these languages that are there. I don't need to read them out. And at one point, I was doing C++. And I had an interview at Cisco to get a job there, and the person who was interviewing me started off really easy. He went, write a factorial function, and I went, okay, fine. And then he went, use templates, so I just added template to the factorial, not really understanding what he meant. And he went, do it at compile time, and I went, what? And he went, compile time. I went, I have no idea what you're talking about. So he ended up guiding me, saying, look, what happens if you write a template that does this, and then at the end, I ended up with what's on the slide there that calculates the factorial compile time. And as soon as I finished writing that, I was like, well, that was clever. I'd never heard of anything like that before, or modern C++ designed by Andrew at the time. I learned later that the person who was interviewing me became my colleague, and he had read that book because he introduced every single concept it had into our code base. And this is how we ended up here, and I thought, this is cool. Why did nobody tell me about this before? I can do things at compile time, that's insane. And so at this point in time, I ended up, let's do everything at compile time, because why not? And templates are amazing. He even taught me syntax in C++. I didn't even know it was valid. That was my first week. I nearly lost my mind. I thought I was going to get fired. And when I learned about string mixins in D, the first thing I thought about when I read it in the book was, you can mix in any string that's known at compile time, and I went, I don't understand what this is for. But I didn't realize at the time that that meant I could run code at compile time and then mix it in, which obviously makes it a lot more useful, because why would I want to pass a string to a function instead of just writing that string myself? And I ended up with just templates everywhere, because why not? Templates are cool. And I had a colleague at Cisco, and he really liked Go, and I still like him despite that fact. And He ended up trying to write some codes to put strings into memory contiguously, and the code, he was really proud of this code, and he said that this was a lot easier in Go, that the only thing that C++ could do, because that was my favorite language at the time, I didn't even know D. The only thing that C++ could do better than this is do it at compile time, and I went challenge accepted, dropped everything I was doing at work, ignored all of my tasks, and started writing code. And only stopped when I didn't know the syntax for something, went on Stack Overflow for the first time, asked the question, gave up, took the train home. By the time I got back to Geneva, I thought, somebody's answered it, hasn't they? It's been half an hour. They knew the exact syntax I was looking for. So instead of going to the gym, I dropped that too, went straight home and started writing code again. I didn't have my laptop with me, so I scratch. And because I'm a massive weirdo, I did a diff the next day when I got to work, and it was a one-line diff. I wrote everything with the same names and the same formatting, because I'm a massive weirdo. So that ended up happening, and that's part of the code which I will not subject you all to in its entirety. The link is there if you want to torture yourselves. And I ended up writing this string class, which is templated on its size, so it can store the thing. Again, I'm trying to do this at compile time. So it has a array of characters with the templated size, and then a const expr constructor that takes a bunch of arguments. Fortunately for me, the way to initialize an array in C++ is comma delimited. Even more fortunately, if I expand the template parameter pack, that's what you get, so that just works. And then, again, this is just an example. It's not the rest of the code, because I ended up recursing up and down. Again, go look at the code if you really want to. And then this function, because this is C++ 11, so you can't do template argument deduction in a constructor, so you need a helper function to construct these things. And you can pass a variadic number of characters in there, and you end up with a string. So foo, because of the null terminator, will have size 4. And that will store that there. And then I had to pack all of them into memory using a tuple. And this will be fun. And ended up with this thing at the end that would make all the strings and put them in memory next to each other, because it's a tuple with a bunch of character arrays. And I challenge anyone to tell me what is that thing inside the parens, which is the parameter to make strings. Does anybody know what that means? That thing with the ampersand there. Because that was the syntax I had to figure out. That couldn't, so I asked Stack Overflow. I knew what I wanted to do. I just didn't know how to write it. Tried a few things, nothing worked, but somebody on the internet knew.
Does that infer the lengths of the strings as template parameters?
It does infer the length of the string as the template parameters, but you still, why is there an ampersand there? Okay. That is a syntax for a variadic amount of character arrays. Because since it's C++, anything that could be a pointer in C can be a reference. So that's a reference to an array. And because I'm passing in strings, it infers the length of the array based on what I just passed in, and it's a variadic amount of them. Yeah, I know. I did say it was the craziest code I ever wrote, and it works, and I didn't know the syntax for that, but somebody on the internet did. Anyway, this is horrible. And the 89-line monstrosity in D looks like this. That's all of the code, not just a fraction of it. It just looks like that. Oh, look, don't need to infer anything. I don't need character arrays. I don't need any of that. It's just whatever. Cool. So I wrote a reflection library. I called it Mirror. And why do I need the library for something that D is famous for? Because it would be nice to have an API that just makes sense. Again, there's many things that you can use in D for reflection. There's double_ traits. And then there's the actual std traits in Phobos. And some of the API returns you simples, some of it's strings. It's not very consistent. What I really want to do is be able to loop over modules and then loop over functions in those modules, or types defined in those modules. If I get the functions, I want to be able to loop over the parameters. For instance, in _traits, I can get a parameter tuple, or The identifiers, they're separate things. I don't really want that. I want to loop over the parameters, have their identifiers, know their types, storage classes, default values, that kind of thing, so a lot easier. So this is the template-based API that you use when you do mirror. You do module, bang, the name of the module. Why the name of the module? Because if I use the actual symbol, I need to import it first. So I'd have to go import modules.types, then pass that in. That's annoying. So pass it as a string, gets imported on the other side. And then type names here is just a helper to go over that module. So it takes the module as an alias because that's a template, not really a real thing. And then it just does a static map over the aggregates in that module, which is what Mirror calls classes, interfaces, enums, and structs. So basically user-defined types in there. And why am I mapping those things to names? Because as you saw in a few talks already, with things like traits as same, it is a massive pain to compare things that are templates or types or anything else, and it was much easier for me to just transform it into strings and compare them for equality. Again, already showing why this is a bit of a pain to use. And then we have that enum name alias symbol there, eponymous templates, everything slightly weird. I'll come back to some of these things in a slide. And then how do you use this? This is code from auto-wrap to wrap things for Python to call into D. Basically takes, again, the module as an alias because it's a weird templated thing. And then the convention is that export functions will get wrapped, but sometimes you want to wrap all of them because you didn't intend for this to be called from another language. And then some symbols to ignore because some things just don't compile and they don't work. And again, need to alias things. So module is a template that takes the name of the module like we saw before. And then I'm just filtering on whether it's an export function or not. But if it's always export, always do it. Then another meta function called shouldIgnore, which is can I find any of the ignored symbols in the identifiers? And then an eponymous template again with a bunch of weird templated things to actually get the functions out of there. So this basically is what are the functions that I'm interested in this D module that I want to then make available to Python in this case, but also C# and Excel. But I think this is Python specific, but this is just an example of how to use the API in the language. So what's good about metaprogramming? Well, I think it's pretty cool. I just like doing it. I mean, weird filters, template knots, and you get to feel really smart and show slides at DConf saying, look at me, I wrote that. And if you miss C++ compile times because you got coffee or you wanted to sword fight, then, well, you get to do that again. And you can justify buying a lot of RAM because you'll probably need it as you do all of this. Trust me, I have run out of RAM. But what's not so good? Well, you have to remember where to use alias or enum for everything, because some things are values and some things are not. And it's not like the compiler tells you what to do, which at least when you get the type wrong, it says there should have been that type, not here. Very annoying. And again, we saw this already in a few places, right? I mean, there's alias, enum, enum, alias. There's no lambdas. There's no such thing as a template lambda, so everything needs an intermediate name, whether you want it to or not. So here, enum is export. Should have been a lambda. It really doesn't deserve a name, but I have to give it a name, otherwise I can't use it. This is even worse with double underscore traits, because you can't pass that to anything. You have to always declare something to be able to use one of those, to pass it to filter, for instance. Using enum to introduce a name means you need curly brackets again. So if you're doing a static for each, you need to add curly brackets again so you can do the enum, so to repeat that name afterwards. Compile times, I joked about it being a good thing, but obviously it's not. How do you debug this stuff? You don't. Drag my message a lot. Readability, gone out the window. Lot tooling, no such thing. And writing tests a lot harder. I ended up, like I said, transforming things into strings because that was just easier to do. I lost it here. Because I tried to compare things for equality, and sometimes it's the same type or not. You can do that with is, but can you pass is in? No, you need a template lambda for that, but you don't have that. So there are things that are just not as easy. And then what's really bad is eponymous templates, for instance, and refactoring do not mix. That means if you rename something, good luck to you. For instance, here, template functions at the top, alias functions inside of it. If I want to rename that because I don't like the name anymore and forget the alias, oops, because things just won't work and fail silently instead of saying, did you mean this? Not really, no, because it's perfectly valid code. There's an alias inside that template that nobody can get to, and it's completely useless. And it's a different language within a language. When C++ 11 came out, I remember Andrew was in a panel, and he said that with constexpr, C++ had added a fourth language, because the first language is the C-like language that you actually call C++. Then there's a preprocessor, and then there's template metaprogramming, and then now constexpr was a fourth language on top. And this is one of those, which is template metaprogramming. It doesn't look like regular D at all. It's a different language. As we saw in Timon's talk, there's ordering issues too. If you do static if trace compiles, good luck with that. I've already seen cases in which if static if doesn't compile, put the thing in so I can see the error, and then it compiles. Compilation errors might be silenced, so if you get the refactoring thing I said before, it might just fail silently because you're checking to see if that thing compiles, and then it no longer does, and then you go through another branch. But that's not what you're meant to do. This happens a lot when you add @safe to something, and then you do something within the function. It's no longer safe. Doesn't compile. Goes through another branch. Fails silently. Just brilliant. And then other things that don't exist in template metaprogramming, like static switch, which has been mentioned already at this conference, but it doesn't exist right now. The ternary operator doesn't exist either, so you have to go static if else. You can't do things in one line. Universal function call syntax as well doesn't exist, so that's something that can't happen. The lambdas are already mentioned. So it's not fantastic. So is there another way? Yeah, there is. How about we do things at compile time with compile time function execution? And then instead of using templates for all that stuff, we can use string mixins instead to generate code, which is just regular code that anybody can write. And you write completely regular functions that everybody knows, and run them at compile time, or not, as the case may be, because you can just reuse the code at runtime. And then use just regular data structures, structs, classes, strings within them, to store the information instead of templated symbols. This is a lot easier to use. And then the way you generate code is by taking those strings that have the information and just mixing them in, concatenating them, all those things that everybody knows how to do already. And of course, these functions that you write can be unit tested because they're just regular functions. So what does that look like in practice? This is an example from the string-based API that Mira has now. I start with structs, and I ended up using a class because there were things that were common to several members of the module. It's a child class of member because that's what I called what's in a module. There are several things that could be in there, so I just called them a member from traits all members. And this just looks like what it says in a tin. I don't think anybody has any problem understanding what any of those fields mean. The overload index is because functions can be overloaded, so which version is this? The attributes that the function can have, no GC, safe, etc. The return type, that type is another thing that has things within it. Parameter, like I said, this is a lot easier to iterate over because I have all the information that I want in there, the identifiers, the types, storage classes, that kind of thing. And then as disabled, there's virtual method. There's things that you might recognize from double_ traits, which is why I put them in there in the first place. And there are disadvantages to this, though, because I do need to import the module that the symbol is in before I can use anything. If I try to mix in the code without that, it won't work. And a template, if you get a type passed to you somehow, it just works. You don't need to import that symbol again within the template. It's, well, you got this somehow, and I can just go t.stringof or t.sizeof. Whereas with mixins, if I get a function, so I call this function called getSymbol that somehow gets me the functional information, I first need to do the import of where that function lives before I can call it. Otherwise, I can't call it by name. What are you talking about? I'm using static import here because, especially since this code is mixed in and not really supposed to be read, I don't see any reason to not use a fully qualified name at all times. That way there's nothing to disambiguate, because why would you want to anyway? So I think this is preferable. And then you just mix in the fully qualified name and then whatever arguments you have, and there you go. This is how you'd call that function. This is pseudocode. Things are slightly more complicated than this. And the other thing that I think is a disadvantage, this list is not exhaustive, this is what I came up with, is that it's really easy with templates to generate code, just to fabricate code out of nothing by just referencing it. So for instance, if I want a function to just exist, I put it inside the template, and all I have to do is instantiate that template and then take the address of that function, and now it magically exists. The compiler will generate code for it, stick it in the binary. All I have to do is reference it at any point in time. So imagine I need a function pointer to call. Imagine, again, I'm wrapping this with Python. All I have to do is function pointer equals that thing, magically there. And with the mixin, I can't do that. I need to generate that function at some scope, mix it in, and then reference it by name. And the other thing that's good about this is that if you have compile time reflection like we do in D, this is superior to languages that have runtime reflection because you get the other one for free. All you have to do is transfer the information over to runtime, there you go. Now, you can't do that with templates because there are no templates at runtime. But the class I showed earlier, this is fine. I can use this at runtime. There's nothing to do. So I can generate runtime type information from the compile time information and just reuse it at runtime. And this enables things like plugins and calling precompiled code at runtime. So you compile the code separately and then call it somewhere else. The way it would look like is like this. Now notice that instead of enum or static immutable, I have const fun, because I could just store this in a regular runtime variable. So I'm showing that you can do that. I have the module which I called mod. I have functions by overload because I realized that depending on what you're trying to do, you might want the functions by overload or by symbol. So you might want to just iterate over all the overloads together and flatten it. Or you might want to go by overload set, and that depends on what you want to do. So you get functions either by overload or by symbol. In this case, I'm doing it by overload. And then I get a thing that has an up call on it, and I can call it at runtime. Of course, for me to be able to call any function at runtime, I need to have a uniform API. Functions have different arity and parameters and all of that. So the way that this is done here is you pass it an array of variant, and then you get a variant back, because that's a uniform runtime API that every function can use. And so I got the function from the module, I call it with variants, I get a variant back, so .get int, and then asserting that I get back what I expect. So you get runtime for free, whereas you wouldn't be able to do that with templates at all. You'd have to have some sort of translation there. And the way that that's enabled for RTTI is there is some ceremony, but hardly any. So you have just a regular D module there. And then there's a template mixin that you can use to basically register it with the runtime type information system. That will generate a global variable called gmodule info right there in module scope, and we'll add it to a list called all module infos that you can then use to query every module that got registered. So in this case, there's only one module that got registered, so all module info 0 for the first one, and then I'm just asserting that its fully qualified name is what I expect it to be because I only registered that one module in this particular test. But this is just an example. That module info there has everything else you need to know, so you can loop over the functions it has or the types and then do what you need to do. And so how do you usually wrap Python? Because I've done this a few times now, but also for Excel and C#. Python is just an example. The way you usually do it is there's an extension module in Python, so you can only do one module at a time. That generates a shared library that you can import. It's got C API, so you can write this to C++ or D or Rust, but it's a C API. And for languages that already have modules like D or Rust, you have to condense all of those modules down into one Python module. So you need to choose exactly how that's going to map. And what you have to do is when you go import foo in Python. First, it looks for foo.py, and if it doesn't find that, there's other things it looks for too. But at the end of that chain, it looks for a foo.so or foo.dll and tries to import that. And it's by convention how this works. So your entry point function into that shared library has to be called pyinit underscore name of library. So it will DL open the library and then try to call that function inside of it, which will then initialize the module. That module def is just a C struct that's in the Python API, at least for CPython. You have to initialize it the proper way, pass a pointer to it to PyModule create, and that will create the Python module. You return that, and now imports that, et cetera, et cetera. So this is what you need to do. By hand, normally, but this is DConf, so we don't do anything by hand. And the normal way, because that's what the API is like, is you need to loop over all the D modules you're interested in wrapping, find all the functions in those D modules, and of course, all of the types and enums as well, but let's just focus on functions here. And then for each one of those D functions that you find, you create a Python C function, which is a type def to a C function that takes 2 or 3, actually, PyObject star parameters, and returns 1 back. The first one itself, because object-oriented programming, if it's a free function, then that self is a module. If it's not, then it's the object that you're calling a method on, and then the arguments, and then also possibly keyword arguments. But this, since this is C, you can just cast the function pointers one to another, nobody cares. And then, for instance, if I want to have a function in Python called the answer that returns 42 all the time, this is what that would look like. So again, the way this usually goes is somebody will handwrite this function because they want to call into C, C++, D, and make it available to Python. So they do this on purpose. Normally, you'd have to get those arguments that are Python objects, convert them to C types, do whatever you want, and then convert the result back. In this case, I don't need anything because the function doesn't really take any arguments, and it always returns the same thing. So the conversion function is take this 42 unsigned long, create a Python object from it, and return it back. So imagine per C developers having to do this for every single function they're interested in and doing all the conversions by hand. Obviously, we can do better, so we did. And that's how I usually do it. Now, before I do it, while I'm doing it at runtime, I got this idea from a project we had at work in which we were actually wrapping our internal language SIL to call from Python. And SIL has a lot of code that's actually written in D. Now, it has a lot of code written in D, and if I tried looping over a compile time, I don't think there's enough RAM in the world to do that. It just wouldn't work. Absolutely not a chance. So the only chance to do this is at runtime, and SIL has runtime type information anyway. So instead of doing this at compile time, what would happen is, dynamically, Python calls into the shared library. I would call into SIL, ask SIL to list all the functions, and then go over each one of them at runtime when Python calls in, and then do all the wrapping. So I went, well, I can do this at D now, because I have RTTI given the way that I'm doing things. And just to show how to do it, I did. So we have the PyModule create just like before. But now what we're doing is, again, this is happening at runtime. So this init function is called by Python when it does the DL open, well, just after that. And we're just doing regular runtime code. There's no templates here. There's no nothing. There's no magic. Regular for each in all module infos, which is that thing we saw before when the modules get registered. And then for each module, we just loop over the functions. In this case, we're doing functions by overload because we need to do the overloading ourselves for Python because Python's dynamic, so you can call the same symbol with different things. And what we need to do is figure out which overload that should actually map to by inspecting the arguments at runtime. So for each overload set, I add a Python method. So that PyMod is a C structure in the CPython API. And then I just pass that function to add method, which is just a thing I wrote. I don't have the body there, but I will on the next slide. Add method just takes the Python object, which is the module that I should add the method to, and then the function, which is that class we saw earlier, and then it does its magic. Again, all at runtime. And then add method looks like this. take the module, take the function, and then I'm just doing a wrapped call there so that I have something that works for any function. As we saw before, I'm calling this with variants. So first, get an array of variants that's the appropriate size for the number of arguments, loop over them, and then convert the Python object to a D variant with that toVariant function. This is a silly example. So in this example, the only thing I handle are integers, because why not? And then I store a pointer within the Python object, which they call a capsule. I have to cast it to the D type that I know it is, because I'm the one that stored it, because it's a void star. And then after I cast it, I can call that function with opcall, pass the variant in, which is actually a list. There's probably a typo there somewhere. Convert it back to Python return. And then for that internal function, which can call any basically D function at runtime, then we have the standard stuff. Create the Python object that has a method definition in it, create the thing I'm going to use to store the function inside of it, and then create a Python function from it and return that. And this is all happening at runtime. But one could do anything else with this, with a plugin system, et cetera, and you get all of that for free. Compile time information got transformed to runtime information, and then you can just use it. And then I'm not sure this library is complete yet because I need something real to use it for. I would have to convert auto-wrap, which is a library I wrote to automatically wrap things for Excel and Python and C#, to use the string-based API instead of the templates to make sure that there's nothing missing there. And then the other thing I wanted to do, which I didn't get to do for DConf, is measure the compile times and memory usage between the two approaches. So take the template version of auto-wrap, do that, and then do this instead and see what the differences are. I'm pretty sure that it will show that it's a lot better, and then profit. And I would also like for people to use it and then find what gaps there are in the API, what's missing, because I'm pretty sure there is. But it's open source, so feel free to create pull requests. And the conclusion to this is that regular D is way, way easier to write. Ergonomic templated code can be a pain. Anybody can write regular code. No, you don't get to boast or feel smart, but you get to get things done. And that the reflection data can just be used at runtime if you see a CTFE, because you can either do it all at compile time or not. You can have an enum equals and then use that at runtime, because the compiler just inserts the information for you. Or again, not. And you get a lot of flexibility, and I think this is a lot better and easier to understand. And you're going to get smaller binaries too, right, because the templates and the symbols are this long. These are links to the libraries that I mentioned. Mirrors the reflection library. Monty is basically the Python C API for D, using DPP to translate the C headers, so that you can use that in auto-wrap, and then auto-wrap the thing I just mentioned. And then I've apparently gone faster than I thought. And so, questions, please.
Questions?
So should this just be what type info is?
Yeah, pretty much. Yeah, exactly. And the good thing about this is somebody was mentioning type info the other day and how it was a pain. I think it was yesterday. This is opt-in, right? Which is better.
So we have plenty of time for questions, so make it a good one.
What is the runtime cost of using this runtime information compared to, as opposed to the compile time information?
I didn't measure, but my intuition would be hardly any. I mean, there's some memory that's going to be used, right, because you need to do the registration thing, but you saw the class. There's hardly anything in it. It's negligible.
I think it's a fantastic idea to make CTFE more desirable or better at this, but is there any plans in the near future to try and make the performance of CTFE better?
Yes, that's literally the next thing I want to work on.
Awesome.
Because at the end, what I want is this. I don't care about object files or linking them. All of that's boring to me. If, like in Weka, it takes me 90 minutes to generate the binary for the custom, I don't care. That's boring, whatever, CI can do that. What I care about is running my tests as fast as possible. So I want to optimize from having a parse ASC to get my tests to run. Maybe the JIT is too much because maybe JITting takes longer than running the test. I don't know. So I'm going to have to somehow optimize for that pipeline because that's the only thing I care about. And it would be even better if the compiler told me which tests need to run given the edit I just made, because I do not care about anything else except fast feedback loops. And as people know, I am a massive weirdo and think that 200 milliseconds is way too long to wait. It's a computer. It's billions of times per second it can do things. Why am I waiting for it? No. So, yes.
So do you think it's possible to actually make a preprocessor for your code to generate this runtime information so you don't actually need to execute it again in another run?
I guess, but I'm not sure I would want to.
For the CTFE, it's also something that Weka suffers a lot because the CTFE is very slow. One proposal that there is on the compiler is implementing a bytecode.
Yeah, that's what I want to do.
Yeah, it's what I was about to ask, is if you were working about it.
So I wanted to finish this first, because I wanted to work on exactly that, but I wanted to be able to, because I thought, look, I don't think the string mixing part of Mirror is finished yet, so finish that first, do a talk about it, then work on the bytecode VM. But yeah, I want that, so. Because I want to do something similar to Weka's doing in the sense of running my tests at compile time, except not really. So I just want to feed it to the bytecode VM and run the test. I don't care. Stop generating object files. Stop linking things. Just no.
There is a 2018 Alexandro talk from DConf that essentially called for systematic introspection, and that's more or less what you achieve. Did you take a hint from that talk?
That's the only reason why this exists, is that talk. And Andrew gave that talk, and I went, huh, that's a good idea. I'll implement it.
So does this paint a picture of the common way that D would be written that's quite different from what people have now with their huge quantities of templates everywhere, which is pretty common, right? Like, it starts to feel like it starts to feel like a different language if you have a completely different introspection mechanism and you're going to build things completely differently. The sort of patterns you're going to do or not do, the trade-offs are all different. Like, it seems to me like you could build a vision of something for the future here.
Sure. I need more people to use it, though, and poke the gaps in it. I can't just go, I'm going to put this into Phobos now, because I don't think it's ready yet. But if it gets used enough, sure. I think that this is the way we should write reflection code. It's a lot easier. And compile times and all of that stuff. Again, I mean, if we didn't have that problem with Sil and Python, I probably wouldn't have thought of this. But I couldn't in the Sil case. It just wasn't going to work. There's just not enough RAM in the world. Looping over, 3 to 5 modules is fine, but 200? Nah.
Any other questions? If not, thank you, Attila.
Thanks.
So we have a 20-minute break, and see you all at the next talk.
All right, we'll back up from upstairs, downstairs, wherever. Hello. Oh, well, yeah, you guys yell out hello to the people downstairs. Yeah, a bit louder. Actually, John, do that in the microphone. This will be fun.
Hey, get up here!
I hope they heard that. It is a bit of a, what do they call it, a sound insulator getting down there? Hey, we got a first-time DConf speaker here. So here's another one from our sponsors at Weka. We have Luis here talking about engineering a real-time, always-on logging system, ND. Fancy that, ND. So applause and take it away.
So, hi everyone. I'm presenting how Weka engineered real-time and always-on logging system in D. So first of all, I'm working at Weka for 3 years now. I love low-level programming, and I've been involved in the ecosystem for a long time, and contribute to a lot of other projects like LLVM and Linux kernel and other stuff. So why always-on logging matters for Weka? Basically, Weka has thousands of nodes communicating with each other, and this needs to be very concurrent, and all those tasks happen all at the same time at a sub-millisecond time window. So we need to have a mechanism to have observability, because a lot of the time problems are hard to debug, and the problems only happen one time, and we need to have it always enabled. So we know that when a bug happens, we can save the logs and the traces and debug it later. So we have some design goals and key objectives for this logging system. One of them is that the logs should be very fast. We are talking about like a nanosecond level writes, and we write like roughly like gigabytes per second of traces. So we actually need to have very fast logs, and we also need to have reasonably fast reads. Because we write a lot of logs per second, we also have a lot of data to process. So we need to have a way to filter it. And we also need to have very unique logs, like a number of unique entries. So currently we have support for 2 to the power of 16-bit. So basically, you have 2 to the power of 16 unique trace IDs, but actually we run out of that number. So like for unit tests, for example, we want to expand to 24 bits. And this basically aims for us to trace every function entry and function exit, almost every function entry and function exit. So we have want to have plus 95% of RCA. So yeah. Another thing is that because we write a lot of logs, the logs need to be compact. The trace entry header, it takes like 9 bytes plus the size of the arguments, and this needs to be. We don't want to trace like strings. We just want to trace like IDs and just put the arguments there and trace it. So another thing is user-friendly experience. So we have tools for reading the traces, filter the traces. We have a filtering language to filter them. So yeah. So what does a trace log look like? A trace log is pretty much like a template that we have. We have several trace types: debug, info, error, and we have a string specifier where you specify what you want to trace, and what is the log about. And then you have the arguments where you, this is basically runtime arguments that you trace. It's not you don't need to have arguments, it's just if you need to have the values. So I'm going to go over a bit about each component of the traces. This is the main components that we have. So we have an instrumenter where we instrument function entries and function exits. We pre-process the source code into instrumented source code with this library. And we have a writer library that has all the routines for writing to shared memory. Basically, we write this information to shared memory, and then we have a dumper executable that dumps this information from the shared memory. It constantly reads that memory buffer and writes to persistent storage, so then we can look at it later. And we have sort of a daemon that has is a server that has several services, and you can connect to ask for traces, so you don't need to have the whole context of the traces. And the printer is pretty much a tool that you can read the traces from directly without a daemon server. And the viewer, it's a client for the daemon. So initially, we produce an executable. After we instrument the source code, we have all these function entries and function exits. We instrument it with the libdparse. So we introspect the code, and at the beginning of the function, we had a function entry. And in the return part, we put a function exit, and also for throws, like for a function that throws, we also have a function throw. I'm going to show you an example in a bit. And this process of producing an executable, we have some internal sections that it's generated at compile time by the compiler, and they sit on the executable. So the executable is full self-describing. So this is one of the examples. Like, it's a very simplified version of the instrumentation of the code. So yeah, it's we actually needed to have this in a inner function because it was easier. Although this creates a lot of problems because sometimes the inner function says that it uses GC because it acts as a closure. We have some mechanisms in the instrument, so this is a simplified version. So what is actually a trace log? The trace log, I said in the beginning that the trace log has 9 bytes. And this is roughly the header structure. So at the beginning, you have like a trace ID. The trace ID describes the log itself, the metadata, all the metadata of the log. It's pretty much an index to one of the sections that I'm going to show later. You have a nesting counter. The nesting counter is pretty much the number of the stack frame that you are in. So when you want to enter a function, you increment the nesting counter. When you exit a function, you decrement the nesting counter. You also have the context ID, which we pretty much use the context ID for fiber IDs, because we use fibers, but this is general purpose. We can use for threads. For threads, it's a bit bigger, but we can have some sort of hashing of it. So we can sort of identify which context we are in. We also have a partial time. The partial time is a diff. It's a partial delta of the monotonic time of the CPU. So it's using the TSC of the CPU to get the time. So we can have a notion of when that trace happened. And the buffer size is the remaining bytes that you want to add to the trace. So if you, let's say you trace a byte, you have to say that the buffer size is 1, so you have the rest of the arguments. So what defines a trace, specifically like the internal section structure? We have these sections inside of the binary that are generated with a bunch of LDC and linker techniques. So one of the things that we use is the add section to tell certain symbol and sort of template to go to that section, and then we later can retrieve it. So the trace ID is pretty much a pointer, an ID, an index that points to a pointer in the descriptor section. So the descriptor section has a pointer for the type metadata section, and then the type metadata section might have other pointers in it. So it's pretty much a tree of metadata that you have. And each node of the tree, it's a symbol that is generated based on the type. So if you trace a string, you would have like a node for the string to know, okay, a string is a list of characters with the this number of bytes. So you have all this metadata in there, so then you can read after. So the trace is very small, but after the reading, you can go over this metadata and crawl it. The other sections that we have a string pool where all the strings are on the string pool because it's in turn the null termination string pool. So the compiler will intern it naturally. The descriptors section is, as I said, is an aligned pointer section. It needs to be aligned to power of 2 because it needs to be efficient to do the calculation of the index. And we also have the channels, which is a feature of the traces, where you can have multiple areas to trace, like multiple shared memory areas. And the type metadata is where everything else is in. So more specifically on the descriptor, what we have in there to uniquely identify the trace, on the template, we have this __ line function and module has a template argument. So every time you have add the trace, it will uniquely identify that trace. And when you view it, you can see that it came from this function, this module, and this line. And you add that information all to the descriptor. And the nice thing of being aligned to the power of 2 is that you can do this calculation efficiently. So you have the descriptor instance, and you subtract with the start of the section, which is a special symbol from the linker, and you divide it by the alignment size, so you can get the ID. And after we have these sections in the binary, to make it self-describing and extracting to externally, like we don't need to have the old binary to read the traces. What we do is we produce a separate info block, which is basically a file that have all those sections separated. And to do that, we need to convert absolute addresses of the binary into relative addresses. This is more complicated with the SOs, with the dynamic shared objects, which it has a base address. And this base address is generated at runtime because of the loader, but it's pretty much like that. Currently, we only use static relocation, so we only have this absolute addresses of the binary. So an overview of what is the trace? So everything that is defined on the template arguments are compile time part metadata. So it will not be information that is going to be on the runtime. The only thing is an ID. And the arguments are bleeded as it is in the shared memory. So that's why it's very fast. You have, it's pretty much a mem copy. So the writing part on the writer library has two things. When the binary starts, you actually extract these sections into the file. And after this, you are able to do a trace call. And when you do a trace call, it will do this copy of the arguments packed with alignment of 1 to the tracing area, which is a ring buffer, which I'm going to talk in a bit. So the ring buffer, it's one of the things that need to be also very efficient. It's a lockless double-indexed ring buffer. And the reason to be double-indexed is that you don't have contention from the writer and the reader of the tracing area. So basically, the writer increments the writing pointer, and the reader will also increment the read pointer. So you can have a lockless way to know if this is full or empty, given that you have memory atomicity, of course, because you want to check that you are being consistent on reading those two values. So on the final part of the writing, we have the dumper, which the dumper will get this information from the tracing area and put it in persistent storage. So the persistent storage will have this info block information. We'll also have an histogram. The histogram is pretty much some increment IDs per trace ID, where you can know how much traces you traced on that minute. And you also have blobs, which is chunks from the tracing area, organized in the way that it's also efficient to read. So this is the reading part of it. So mostly the daemon and the viewer, it's what we use more frequently, because what we want to do is have a viewer that accesses the daemon to ask for traces, and the daemon stays on our server that has all contents of a persistent storage. So the daemon will go over each blob and try to get what the viewer is querying. For example, if the viewer wants to have just debug logs and only want to have 100 debug logs from that time span, it will ask for the daemon, and the daemon will only give that result. So this is a good thing for getting the traces over the network, so you don't need to read millions of traces there. And the data structures that we use for the blob itself need to be efficient for reading. And one of the things that we have is we have a header that tells for this specific chunk. Each chunk is more or less 1 megabyte. That tells you in what timestamp it started and what timestamp is it finished. So you know that this trace is within this timestamp. And you also have a way that tells you how many lost traces you had, because this may happen to not contain the tracing area. Like you may write to the tracing area and it's full, so you, instead of writing to it, you just skip it and increment that number. So this stays also on the header. And then the data is, you pretty much have everything related to the traces arguments, and all the data for the traces. And the footer, you have a bitmap where each bit is flipped whenever you have that trace, or you may know that that trace is there. Currently, this bitmap is actually 16 bits, so you roughly have like I think it's 8K of size. But if we have more bits, like if the trace ID is bigger than 2 power of 16, you need to have just like a probability of being there. So yeah, this bitmap is used on the filtering part, which is a good way to skip 1 megabyte chunks at each time. So the filters is something that I actually kind of over-engineered, because it's something that I really like about the. I really like languages, and how to create them was very fascinating to me. So we created a small language to expressly filter the traces. I used a packed library to parse this language. It's a very simple language where you query certain, you say that you only want to certain type of traces. Maybe you want to filter by the format specifier. Maybe you only want to have traces from a specific function, so on. And basically, this language will compile the filter into an AST. The AST will be just a syntactic representation of the filter, but you can have a way to optimize this filter by just pruning nodes from the AST. And for example, if you have like debug or log filter, I'll go into explain this in a bit with some examples. But pretty much, you can have optimized filter in the AST level, and then you convert it to a level filter, which we call it low-level filter. So it's pretty much very basic building blocks for filtering, where you say it matches or not. You compare offsets within the trace entry. So when you compare offsets and you say it's a hand or an or, you match or doesn't match that trace, and you run this tree, a very low-level tree, to match if the trace match or not. And we also have optimization on this level of tree, and this is the most interesting optimizations because you have the context of the metadata of the traces. So before you're running on all the traces, you go over each metadata and see if this matches or not. Because, for example, if you want to trace for a debugs, you already know that specific trace IDs doesn't matter. So you can already discard them before filtering. And when you filter, you just check if the trace ID is that. Otherwise, you just skip everything. And this trace ID pruning is also very important because you can create a bitmap similar to what you have on a chunk. And you can compare the bitmap and see if any trace is there. If it's not, you can just skip the whole chunk. So this is some examples for a filter. This is a very simple example. But imagine you have these 3 traces, and you want to have this filter. You want to log filter by logs or debug, and some the first variable that has the name something as a string. And because log is supposed to be equivalent as a debug warning error, you can already optimize it to just log. This is basically the AST optimization. And then on the low-level filter part, you you may have some never match node or matching the string something based on the trace ID that you want to generate. Remember that these low-level trees, they are generated per trace ID, so you have a per trace ID optimization. I'm going to do a little demo of what we have. So hopefully it works fine. And this is on the other screen, so maybe it's a bit more complicated for me to do it. Let me replicate the screen real quick. Okay, cool. So this is the viewer where you have all the traces. I'll show you how it looks like. So this is the trace files that you write. You get from the dumper gets these trace files from the shared memory and dumps into files. This is 128 megabyte files. They can be smaller if they don't have this amount of chunks. You have these histograms where you can read them. Currently, reading the histograms is failing for some reason, but yeah. And this is the metadata file, which is hashed, so you know that you don't need to have copies of metadata file that you don't need. So with the printer, you can actually print the traces that I did. This is a very simple program. You can see here there is some demo traces that I created. And we have all of this. This is exceptions. So exceptions will have all the trace back here. This is currently only with pointers, but it's able to resolve these pointers into strings and lines. This is like function entries and function exits. The interesting thing with the printer that is mostly used for debugging, you can list all the types inside of the info block. So you see here unsupported type. It's pretty much because I didn't implement support for reading this metadata information, but it's actually supported. It's just not support to read this internal information. This is the relative address that you see that are extracted from the sections of the binary. And for example, for this type, you have like a static array with size of 15 with no qualifiers. Actually, I don't think the qualifiers are listed correctly because currently we don't use the qualifiers information, but it's all metadata from these functions. For example, here you have a struct. This struct has this 3 anonymous fields. So all this information is there, and the reading part will read this information to translate the trace to human readable. You can see here this is the viewer, and you can see that I can do a filter. For example, if I filter just by info traces, you can see that it already pre-filter the traces. When I hit enter, you see that it searches the traces on the trace files. It asks the daemon to filter it by you. Otherwise, you filter by the local filters that you have on the viewer. And another thing that you have on the filtering language is that if you type something that is wrong, you see that it gives you some hints. So I made some sort of linter for this filters, where you actually, if you write something that is wrong or something that can be optimized, like for example, true and true, this will optimize it its way. Maybe if it's some more complex trace, you will see some other warnings. But basically, you have the scenes. Another thing is that, because this is a rewrite of a project, an existing project that we have, we may want to transition from one filter to another. And we have a way to deprecate certain syntax. So if you, for example, if you say info without the hat, it will say, don't use the hold selector expression syntax to use this one. This may change later because the filtering language needs to be tweaked. But yeah, you can filter by just functions, or for example, you see this function was traced on fiber ID 3. You can say FID 3, and it will trace. Will check only for fiber ID 3. This meta traces will always happen because it's meta information. This trace should always happen. So it's good to always have them. If you don't want them, you can just say add no meta. For example, add no meta and info. It will only show the info traces. Yeah. So Weka is hiring. So roles are open. So feel free to fill them up, and we are happy to see you. And thank you.
All right, you know the deal. Hands up for questions right here.
Great, thanks. Good presentation. I was wondering, do you store the log and the tracing data on the Weka file system itself?
Well, we don't, but we can. It's just currently we use we want to do a more complex way of storing the instead of being in precision storage. Maybe we want to offload this, but currently we store it on a specific drive. But because Weka is just, you can just mount it as a local file system. Why not? You can do it.
Cool.
How do you decide what ID to use, or which ID, what kind of ID are you using?
So you don't decide, like the IDs are all generated. You don't know that a certain ID will match this trace. It's just a way to identify it. So you have this ID of the trace. This is only for internal use. If you want to filter by ID, you can, if you know that specific trace. But mostly what we use to identify the trace is either the format specifier, like the string, because this string is mostly unique. Unless you want to know a function, if you want to know a specific function, you do function equal and the name of the function. So does that answer your question?
I was just thinking whether you were using something like a UUID type thing, or whether you're using a timestamp. But it looks as if you're basing it on.
It's just it's just an index. It's an offset. Okay. So it's not UUID like.
Since you only store the delta time in the header, if you want the absolute time, do you have to sum up all of the logs, or how does that work?
Yeah, so it's a bit more complicated than just summing up the delta times. We have special traces. So imagine this is a partial diff. If you have something that overflows this partial diff, which is just 16 bits, and the TSC increments very fast, you have a special trace that you can have the full size of the TSC, and this is absolute. It's not relative. So you don't need to do relative calculations between them. If you only have relative traces, this happens when you trace very fast. You need to do this calculation. But this only gives you the TSC value. You need to have something comparable. So we store also the frequency of the TSC, and we also store the wall clock. So with all those three values, we can know the absolute timestamp.
Is there a lot of overhead with the function enter and return logging? Like I can imagine, in D where we have a lot of abstractions that are fast when you inline, that there might be some interaction with the logging there.
Yeah, so we have something called @noTrace, where specific functions that are likely to be inlined are not traced for that specific reason. Also, we also have a limited space for traces, like trace IDs, because we have thousands or more than maybe millions of functions if we consider the auto-generated functions. But we don't want to trace like every function. We want to trace most of the functions. And the override of the function entry and function exit is the same override of a normal log. And as I said, it's like sort of like 4 nanoseconds of speed, because it's pretty much mem copy. So there's that.
Do you make any use of the dwarf debug info?
Oh, yeah, sorry. Yeah, I use the debug info mostly for the exception handling. So if you want to know, like, not just the exception handling, I mean the backtrace. So the backtrace is a full, just a list of pointers. And to resolve those pointers, what we need is to go over this debug line section and run the virtual machine of the dwarf and get the addresses. Actually, what we do is convert into a more simple way to get those pairs, because it's actually a bit slow to run the dwarf. But yeah.
What's the compile time overhead for the thing?
Well, the compile time overhead is a bit, because it's all templates, and if you go over each type, like if you trace every type and you want to go over each type recursively on the compiler, it takes a lot of time. But this is a minor issue for the traces specifically, because like AL, for example, showed you before, we also have upgrade and downgrade types, so we also go over each type recursively anyway. So, and I think these two things abuse templates a lot on D, so yeah, the compile time overhead is a lot. I don't have a measure of it, but maybe we want to improve it if it's too bad. We need some tools to know it, actually.
Thanks.
All right, let's do one more good question to wrap it up. Good one, come on. You've got a good one in you. Where is a good question? All right, you've got an ordinary question in you. Where's an ordinary question? Okay, what about a bad question? Can we do a bad question? I don't think we're getting a bad question. We do have a hand up. Is it a good, bad, or ordinary question?
Ordinary, I guess.
Ordinary.
Any desire or interest in open sourcing it?
Yeah, I think there is some interest on open sourcing it. Currently, because this is a right of the existing project, we want to have it integrated and stable. And maybe later we will think about open sourcing it, yeah.
All right, with that ordinary question, we're done. Thank you, Luis. All right, now we've got about 20 minutes for you guys to have a break before we kick off the final talk before lunch, so enjoy. Right, are we all back upstairs? You all had the loud Australian treatment again, so I assume you're back upstairs. Yes, I did. Yeah. Hey, look, see, here's our loud Australian down here. I don't think the camera can catch it, but hey, Nicholas, he's employed by the D Language Foundation these days. You show us your loud Australian voice.
Well, that's probably not a great idea.
Why not? The internet wants to hear it. Ah! Are you awake now? You should be awake because we've got a first-time DConf speaker up here. So take it away, Ben. The last talk before lunch. Enjoy, everyone.
All right, morning, everybody. I'm really excited to be here. I've watched a lot of YouTube recordings of DConf talks. It's fun to actually see them live for the first time. Also, I feel like this is a good talk because almost everything in it is connected to one of the other talks I've seen this week, so I'm in the right place. So about me, unlike a lot of the people here, I am not a professional software engineer. I'm a teaching faculty member. I teach at the University of Utah. I teach mostly in a program called the Masters of Software Development for people that got a whole undergraduate degree and then realized that they actually should have gotten their bachelor's in computer science. Oopsie. And so we try to get them on the right track quickly. Before that, I did my PhD at the University of Utah in graphics. I worked on physics simulators for games and special effects. And most of that stuff was written in C++. Because at the time, if you wanted high-performance stuff, everybody wrote things in C++. And I had an internship at Adobe, and my manager was really excited about some of the new stuff in C++ 11, which at the time was still C++ OX. Cool things like lambda functions and unique pointers. And that kind of got me hooked into learning more about modern C++. Reading standards proposal papers, and eventually that led me to some stuff from Andre, which is how I got into D. So that's a little bit of my background and how I got here. So I'm going to put a big warning up for the rest of this talk. None of this is production code. It is all mostly finished projects that are on my private GitHub page. So one of the advantages of being in academia is that my code doesn't have to be great. And so take the ideas that I'm going to show here with a little bit of a grain of salt, although I feel a little bit more confident having seen similar ideas in a lot of the other talks this weekend. Or this week, sorry. So the main thing I'm going to talk about is converting back and forth between byte arrays and D structs. Right, so generally, this is just parsing data that is in some format. Might be textual, might be binary. Right? But if we're going to be dealing with stuff in code, we want structs in memory that we can operate on. Okay? And I think all of us have written code that goes in both of these directions. It's not particularly complicated code, but it can be pretty annoying, especially depending on the complexity of the format of the data that we're dealing with. And so the talk is about how to implement that arrow with as little user code as possible, and some of the abstractions that I have come across that are helpful for doing that. So the inspiration came from learning about the pegged library, which Luis just demonstrated is useful in the real world. And the idea there is you can specify a grammar for a language using a string, and then pegged will give you a recursive descent parser, which will parse that for you and give you back a parse tree, which you can traverse and do whatever you need to do. And so I learned about pegged, and then I've also kind of been interested in the DMD compiler. It's the very important tool for all of us. As trying to understand it better, one of the first places I looked was the parser, both because that's the first place your code goes, and also it's one of the simpler parts of the compiler compared to the semantic routines. And so I was kind of thinking, could something like pegged be used for the DMD parser? Okay. And I realized that not quite, or at least not directly. because I don't really want a pegged parse tree, or DMD doesn't want a pegged parse tree. It wants a module or an expression or a function declaration or something like that. So if we wanted to use something like pegged for the DMD parser, we would define the grammar, use pegged to get a parse tree, and then we would have to convert that parse tree in a second step. And so I was wondering, is there a way to do this in one shot? Can we get something like pegged where I don't have this intermediate representation? I go directly to the structs that I care about. Okay. And so the experiment that I did here is the autoparsed library. So the way that it works is you take your normal structs or classes, or, your AST nodes that you would normally have. You add an annotation to the top that says what the syntax for that AST node is. And then autoparsed is going to generate a recursive descent parser for you based on that annotation. And you just say parse, give it the type that you want, you give it the token stream. So I've implemented some of the quantifiers and regular expression type things that PEG provides, just kind of basically enough to do proof of concept. So I have things like optionals and repeats and that kind of thing. Okay. So what does it look like to use this? You just say, hey, I would like a statement, please. Here's my token stream. So what is a statement? Well, in this simple toy language here, a statement might be an expression statement or an expression. And then, so going down one more level, what is an assignment statement? Well, the syntax for that would be some identifier, an equals tokens, and some sort of other expression. Okay. And then when I am actually creating an assignment statement, I don't care about the equals token, so the constructor is just going to take the identifier and the expression. Right? Those are the relevant pieces of data when I'm parsing this. Okay? And so as far as autoparse cares, we really just care about the syntax annotation and the constructor signature, and then everything else is just normal struct stuff. Okay? So based on this, autoparsed is going to generate a recursive descent parser. So it's going to, if one of my AST nodes has, in this case, like an identifier is the first thing I'm looking for. Identifier is going to go through the same machinery. We're going to find the syntax annotation, create a parse overload for that, and so on. Okay. And the only part related to parsing in my AST are just these annotations at the top. Okay. In this case, the one of rule that says my statement could be one of these two types, I use some type in the return to give you one or the other. Okay. So we have these rules for parsing. We need a token stream to parse from. Parsing from getting the token stream is actually basically the same problem. Right? I have some kind of primitive tokens here. And I have some more complicated tokens like white space, which could be any group of white space characters in sequence. And so I can use the same syntax rules to describe these tokens. Here I'm showing off a couple of the more some helper functions here for describing syntax. So in this little language, an identifier is some mixture of hyphens and lowercase and uppercase characters. Okay. And then once I have this, the lexer is just a forward range. The types of the parse rule, what it's trying to parse is one of any of the tokens. And then it just has a nullable for front. And pop front just calls parse to get the next thing. And so it reuses the same machinery and all that sort of stuff. So as I was building this, I started writing a lexer and realized, well, actually, I kind of have all the machinery I need already, and I can just repurpose it. Okay. So here's an example of the type of grammar that you could produce with this. So here are my tokens for a simplified S expression grammar. So I have parens, I have white space, or I have an atom, which is just anything that's not parens or white space. And then I have an S expression class, which is a paren, one or more atoms or nested S expressions, and another paren. And then I have the constructor, which just takes the array of the members. So I have tested this and played with S expression grammar, a JSON grammar, and a C kind of like simplified C kind of grammar. And things seem to work pretty well. Some nice things about this. The AST nodes, really, aside from the syntax annotation, they don't say anything about the parsing. So most of my AST node code is just the code I would write anyway for my AST, and I just add a little bit to the top. There is a little bit of an implementation leak here. So the type of the parameter has this like one of node type thing in there to connect the syntax annotation to the parameter. Currently, all of the parsers for like a regex star, regex plus give you back an array that's dynamically allocated. It would be nice to return a range there to avoid that. But that turned out to be a little bit tricky because you have to make sure that you drain that whole range before you try to parse anything else. So for the S expression example, right, I have to make sure that I parse all of the members before I try to parse the closing parenthesis. And so that turned out to be a little bit tricky. But overall, proof of concept kind of does what I want. And maybe this is a good idea. Okay. So going back to kind of my initial motivation for this, I kind of was thinking back, how does this compare to the handwritten parser that's in DMD? Okay. So I'm not employed as a D developer, so a lot of my D writing experience is kind of hacking on the compiler. One of the things I do there is just try to read through the code, see patterns, find places where maybe there's a space for a better abstraction. And looking at the parser, basically all of the parser methods are like, parse this sequence of tokens or sub-expressions in order, and if you find something you don't expect, error out. Right? In autoparsed, there's one parse overload that does this. It takes a variadic list of template parameters and then just parses those things in order. And so that shows up just one place in the code as opposed to every single parsing method. Okay? And so I'm not here to say that this is a better thing, but it's definitely a different abstraction with different trade-offs. So I thought it was cool that I did capture something that is inherent in the handwritten code in a different way, kind of a more programmatic way. And so I thought that was it showed that this experiment kind of worked how I was hoping. Okay. I'm not planning to try to replace the DMD parser anytime soon. But I was happy that the idea kind of worked. There's some other benefits that come with this approach. So the grammar is code. It's these syntax annotations. So if the grammar is wrong, then if you try to parse something, it won't work. So you'll find that out right away. And also because it's code, I can do introspection on it. So for example, if I have a grammar, I can find all of the syntax rules, so all of the syntax annotated types. And I could, in this case, I'm just going to print them out with pragma message, but I could use this to automatically generate the documentation or do some sort of verification. So there's a lot of stuff I can do because it's code. Okay. And as an example of where this might be useful, here's a bug report from DMD where it didn't look too closely, but at a cursory glance, the grammar and the spec didn't quite match the way that the parser worked for this particular case, right? And if the grammar is code, the grammar is the code of the parser, then you can't have problems like that. Okay. Another nice thing is, pretty much all of the issues could be improved with a better implementation. Okay. So the users of the library don't really say anything about how the parsing should be performed. They just say, hey, here's the grammar. So in theory, you could replace the recursive descent implementation I have with something like an LR parser, or totally change how the parser implementation is. And maybe it's completely transparent to the user code, or maybe you change the import to import a different parser type. And again, my AST nodes, they just say, hey, here's what the syntax is supposed to be, and they don't say anything about how to do the parsing. And there's lots of other things I could fix inside of the implementation for better error handling or whatever else, right? And the actual parser code is really compact as opposed to being spread out like for each of the various types. So the changes to make might be tricky, but they should be isolated to one small part of the code. So yeah, that's the first project, and yeah, it was kind of pushing some of the ideas from Pegged and seeing where we could get with that. And I'm more or less happy with the results there. The second part comes from a practical problem that I have in my actual day job. So I am a professor, and when I'm lecturing, I need to show stuff on the screen for my students to see. And one good thing about COVID is when I was teaching over Zoom, Zoom has a feature to share a single window with everybody, which was really great. If I want to show slides, I just select, say, hey, show the slides. But I could switch to showing a text editor or a terminal window or my iPad. And when I got back to teaching in the real classroom, there wasn't a way to do that. So I wrote this tool called Presenter Mode, where I can pick Windows or iPad and put that on the screen for students. This is unfortunately not written in D. This is a Swift UI app because it's all Apple stuff, and that was easier. But this is the tool I use literally every day in my job. And I added a feature about a year ago to record videos of the lecture directly from the app, so I didn't have to use some external screen capture tool. And that was pretty cool, except that periodically the app would just crash, and my video recordings would break. So that was pretty annoying. So what was going on here? I'm recording videos in MP4 format, which is an atom-based format. So it's a file made up of atoms. An atom has a 4-character type, a 4-byte size, and then some data specific to that atom. So here, this is a track header atom. And so an MP4 file is just a bunch of these atoms. And from the size, you can jump from one to the next and go and iterate through all the atoms in your file. Okay. So when you write an MP4, you start by writing this file type atom, which just says, hey, this is a video MP4, a little bit of just very basic format information. And then when you start writing frames of audio and video, you start with a media data atom, which is initially empty, and then you append the data for each frame as it comes in. So this means you're going to have interleaved video and audio. Right? At each frame, you just add to the end of this atom. Okay? So this would be very difficult to play back because there's not information about what the encoder is or where to find the frames at a particular time. And so that all goes in this move atom at the end, which says, hey, this is H.264 with AAC audio. These are the tracks in it. This is the resolution. And a really important thing is it has a big table of offsets from the sample, sample number, so which frame of the video, to byte offsets in the media data atom, so you know where to find the data for a particular video frame. And so when my app was crashing, it actually just didn't write this. Even though all of the video data and audio data was in the file, it was basically completely inaccessible because this move header, which says how to interpret it, was missing. Okay. And so I was pretty annoyed. My students were annoyed. My lecture recordings weren't available. And I looked around to try to figure out how to repair these files. And there's a lot of really shady internet ones that want you to upload your broken video file and then watch some ads, and they'll email you the results. Okay. I couldn't find a good tool that I could run locally, but I learned enough about the process to figure out what's going on. So you provide a working MP4 file that uses the same encoder, and then your broken file. And then basically they copy all of the, what codec are you using, what the bit rate you're using, that kind of stuff, assuming that it would be the same. And then they look through the MDAT chunk to try to infer what the offsets are and then they reconstruct the move atom and add that to the end. And so since I was unhappy with the existing tools for doing this, I thought, okay, well, I'll try to write my own. Which meant that I had to understand the MP4 format and look at all of the various atom types and figure out, what's in these movies. Yeah. So here's an example of one of the atoms in MP4. It's a track header. It's got a bunch of fields in it. Nothing too complicated here. So these atoms contain a bunch of fields, including other atoms, so there can be nesting. The simple data, most of the fields are big endian integers of a fixed size, but there's some other types like fixed point integers or byte arrays, stuff like that. And to looking at the files that I had that were working from the Apple encoder that I used, there was maybe 10, so maybe like 50 or so of these atoms. And so, I wanted to have a simple way of taking this kind of documentation and getting something that I could use in code. And I started thinking, okay, well, like how do I represent the contents of the atom? They've got, these fields have like names and sizes and some data representation. So maybe I have an array of those to represent an atom. And thankfully, pretty quickly, I realized that this was really stupid and that there was an obvious, better solution to this sort of structure I was coming up with. I assume you all know what it is. I just want to describe the layout and contents of a data type. A struct, yeah. So it took me a little while, but not too long. And yeah, obviously, the struct is the way that I should define these atoms. But the in-memory layout of a destruct is not going to match the layout on a file in an MP4. So the destruct is the right way of describing these things, but I can't work with the raw data directly. So unfortunately, I cannot just do a memmap and cast. So I have to deal with the endianness issues and also alignment and padding issues. But for the user of the library, they should deal with the atoms like their normal struct. So when I'm defining what is in an atom, I should just make a struct definition. And then when I'm interacting with one, I should be able to work with it just like it's a plain old struct. Okay? And it turned out doing that sort of translation was really easy to do in D. Okay? And that's because of opdispatch. Right? This allowed me to create a mimic type, an imposter type, that has the same, I can access the fields the same way that I would with the real struct, but I can have code behind it to do whatever I want. So for each of the fields in an atom, I need two opdispatch overloads, one a getter and a setter, one with no parameters, one with the field type to set with. And these basically just need to figure out, okay, where is the offset in the byte array that corresponds to this field, do endian swaps, and then either read or write the bytes there. The offset of was, I can't use offset of directly. I guess I probably could have used pragma pack or something, but I opted to just compute the offsets in the atom based on the struct definition. And as Attila mentioned, doing metaprogramming is not that fun, but doing CTFE is really easy. And I found that I can grab the field sizes from the using the traits, put that into a range, and then I can just use standard algorithm to do partial sum to figure out the offsets of stuff. So actually, most of this code was just normal decode using Phobos that I just ran at compile time, which was really great. I used standard bitmanip to do all the endian stuff. And basically, the end result of this is this function template remapped. You give it a byte array, you give it a T that you want to mimic, and then it returns this wrapper type, which you can basically treat as if it is the struct. And the total implementation here was like less than 300 lines, and that's including a bunch of other features that I'll talk about in a second. Okay. So user code, say I have a struct definition, and I have a ubyte that should store the remapped version of the data. I just say, hey, remap this byte array like it's the struct. Okay? And then I can use my opt dispatch overloads to read or write fields as if my wrapped type is just like the struct. I also implemented opcast. So if I want an actual D in-memory struct, I cast my wrapper type. And again, this was really easy to write in D. It's just a static for each over the members and just use the opt dispatch that I already wrote. And then I also have a op assign overload to go the other way. So if I have a native D struct and I want to store it in memory in this format, I just use my overloaded op assign to do that. Some other features I implemented, if you have an array of these types, I'll give you back a range, a random access range of the wrappers. And it turned out that some of the atoms used bit fields. So I came up with a UDA approach to do bit fields in this as well. Okay. So remapped is the part of the library that handles this. And it's kind of general purpose destruct to some ubyte array format that you can't control converter. So there's a bunch of MP4 specific stuff that D also helped with. For each of the atom types, I created a UDA that takes the 4-character name. And I can use that to do all sorts of introspection. So one of the things that was really helpful was to be able to dump a whole MP4 file with the proper types for all the headers. And so I wrote a recursive dumping function that uses this the UDA to figure out what struct type the atom corresponds to, convert, remap it to the appropriate type, pretty print it, and recursively traverse to any nested atoms inside of that. And all of this code was really short because it's a lot of static for each. So as I was exploring and understanding the MP4 file, I would write a struct, run my dumper, see the children atoms inside of it, go to the spec page, define a struct, add an annotation, and then when I rerun it, that struct, that atom now gets pre-printed, and I can start to understand the file, see what all the pieces are. Okay. So here's an example of what that code looks like. So I just have a normal destruct, which is more or less an exact translation of the MP4 spec into a struct. I add the UDA, and this registers it with my dumping code, and so I get this traversal stuff basically for free. Okay. So takeaways from this project: destructs are the way to describe data layout. Right? That's what a struct is for. And the great thing about D is it doesn't really matter if your format doesn't match the in-memory D layout. It's malleable enough to interoperate with whatever format you need. I thought that was really great that I was able to do this in very little code. Yeah. Get symbols by UDA is like magic. It's a way to do opt-in kind of registration, and it's a really powerful tool. Okay. So that said, metaprogramming is powerful, but can be tricky to work with. So in writing these sorts of declarative libraries where the user might interact with it with like just a UDA and like one function, if they get a compiler error that has a deep stack trace inside of this library code, it's pretty awful. As I was developing autoparsed, this happened to me all the time. Mostly because I was screwing up the implementation, but sometimes I would define a syntax annotation that didn't make sense. And the error messages that you would get are pretty awful to look at. It was really important for me as a library author to kind of find the places where the implementation could leak and provide my own better errors. The ideas from the Weka talk on Tuesday were really awesome, and I will look into adding stuff like that as I keep working on this. Another pretty common tricky problem that I ran across is if you have an opt dispatch overload that has a compiler error in it, then it's like that overload doesn't exist. So usually the error wouldn't really tell you anything about what went wrong. Thankfully, the compiler does warn you. It says, hey, you might just try calling opdispatch directly, and then you actually do get the ungagged error, but not the most ergonomic system. And I kind of knew about the issue of swallowing errors being tough to track down, and so I don't think I have traits compiles anywhere in my code, but I kind of ran across the same issues dealing with opdispatch. Okay. I think one thing that could help here is for the compiler to track overloads that fail to compile. And if you end up with an overload set with where all of the potential options have failed to compile, you could use that for a diagnostic. And if at least one, or I guess if exactly one of the overloads does compile, then you pick that and you ignore that you ever considered these other ones. But I think that it might be helpful to just track, say, hey, like, yeah, I know you tried to do this opdispatch overload, and it didn't work, so here's the error message. Another thing that would be helpful would be template lambdas. It's not the end of the world to assign a name, but it would be nice not to have to. And then, working with static for each, it's very powerful, but declaring variables inside of static for each gives you the duplicate variable declaration, which is annoying to deal with. Sometimes you can add another curly brace to get a scope, but that didn't always work. And so what I ended up doing was not using variables and just repeating myself over and over again, which I did not enjoy. But eventually I came up with what seemed to be a pretty good solution. I'll expand on the seemed to be in a second, which was the sort of analog to extract function or extract method for this type of code is template mixin. So I can pass the code the expression that I'm repeating as a parameter to a template mixin and then mix it in. And that was a way to avoid some of these problems. Although I uncovered a bug in DMD as I was doing this, if you mix in multiple opdispatch and also operator overloads before I fixed this bug, it would not consider all of them, and so only the first one would exist. But that should be it's fixed. I don't know if it's in the most current the current release yet or not, but hopefully it should be in there soon. Okay. So these projects required a lot of metaprogramming. The great parts of metaprogramming are when it's not metaprogramming and it's just CTFE code. And I was kind of surprised at how many places I could just write normal code and use enum to evaluate it at compile time. But code that does deal with types has to be, at least as I implement it, did have to be lots of templates, lots of traits. And when writing this code and you get compiler errors, it's not easy to understand when you have a backtrace that goes into the result of static map, right? It's pretty miserable. And so yeah, the way that I tried to debug these things, so I just put pragma message everywhere. So okay, what are the parameters to this template? What am I instantiating? What's tons and tons of pragma message. So I'm a professor. I deal with students all the time, and I have actually seen students behave this way. They're trying to debug code. They spray printf everywhere, which sometimes is fine. I do that in my own runtime debugging, and sometimes it's very useful. But when I see students doing this, I tell them to reach for the better tool, which is, of course, a debugger. So to that end, I have a modest proposal for a compile time debugger for D, which I'm calling pragma breakpoint. So the idea is when you do semantic analysis of a pragma breakpoint, it just pauses the compiler and gives you a simple debugger interface. I think two very useful starting points would just be backtrace. So like, what am I doing semantic analysis on right now? And a way to print variables. So what AST nodes am I analyzing? What part of the analysis is done? What have I figured out? Okay. So I think this would be a really useful tool for dealing with these types of template metaprograms when we have to write them. Seems like it should be doable to implement, and I'd love to hear what other people think about this idea. So to conclude, D's features let you write succinct programs in a way that you just couldn't do in other languages. Even languages like with reflection like Java, it's just not, it doesn't have the same power as D. CTFE is awesome, and the template stuff is useful if sometimes unwieldy, but it allows you to do things that are pretty awesome when they work. So D lets you write high-quality declarative style libraries where the user code, might just be an annotation or just a call to a function template. With those powerful libraries, the authors have to be careful to make sure that the details don't leak into the user code, but there's ways to handle that. And finally, I think the existing tools are powerful. I think there's more we could do to make writing these types of libraries easier, and a pragma breakpoint might be a way to do that. So to conclude, all these projects are on my GitHub. So autoparsed and the remapped are up there. Presenter mode is up there too. If you use a Mac, I recommend checking it out. And with that, thanks for listening, and I'm happy to take any questions.
Oh, we got a few, so we'll go here first.
All right, cool. Did you try, when you did the peg thing, so you reflected on the grammar and then printed the pegged out, did you then try using pegs to use the parser for that and then compare the two?
I did not. That is, I guess my output is not formatted how pegged, in
Yeah, but you could, right?
rules. But yeah, I think you could totally do that. Yeah.
Just as a test, like, did I get the grammar right?
Yeah, that's an interesting idea.
Okay, I like your work on the autoparsed. Are there any constraints on the grammar you're aware of?
So I basically implemented the same rules, or a subset of the rules that pegged does. I guess it's been a while since I took a formal PL class, but whatever the restrictions are for what you can write a recursive descent parser with is basically what I'm working with so far.
And another question, I have seen that you use structs, but I'm not sure if I overlooked it, whether there was some class as EST node. Have you considered having classes?
Yeah, so I support both, and basically I have a helper function that either calls new or doesn't, depending on whether I have a struct or a class. Okay. So for autoparse, that's basically the same.
So early on, you said you had problems with returning a range because you needed to keep data in memory until you were done with the thing. And this just kind of sounds like what IOpipe does.
So it's not quite that it has to stay in memory. It's that, so if I parse an S expression, I get a range that's like pointing at the first thing in the parentheses. I have to make sure that I drain that range so that when I try to parse the closing parenthesis, like my token stream has advanced there. So it's not so much about storing stuff in memory, it's making sure that I advance the lexer for the next part. And it was tricky enough to find basically where I need to iterate through the range to do that, that I sort of gave up before this talk.
Okay. And the other thing is, I love model-based programming. I think that's fantastic. And every time I see a string-based model specification like pegged, I'm like, oh, that should have been a struct. So that's exactly where we should go. Did you consider taking the MP4 spec and building your structs from that?
I guess the documentation that I found was on the Apple websites. I'm sure there must be like a more easily digestible format somewhere. I think in theory it should work to be able to do that, but I didn't look that hard.
So about the pragma breakpoint, you can actually do it in two ways. One is I think actually LDC has some intrinsic for that, but regardless, you can use an inline assembly to do a UD2 to like create an actual wrong instruction, so it will hang the debugger. But one thing that you can also do is use a custom signal where the debugger just listens for that signal, and whenever you fire that signal, it triggers a breakpoint on the.
So you would run the compiler and the debugger, and these would pause it at those spots.
Yeah, you could just create a function with those helpers, and yeah.
So sorry. So about the op-dispatch issue, we've encountered it as well, and there is, at least there is a 99% workaround, which works pretty well, where you can split your op-dispatch into an outer template and an inner implementation, or basically it's another template. And the idea is that the outer template determines whether the member exists, and it's very easy to instantiate. There's very little code that needs to have no typos and be correct. And then the inner template needs to be instantiated to get all of the massive code. And the idea is that whether the symbol exists only checks the outer template. And then when you try to call it, it will implicitly instantiate the inner one. And that solves the problem because you don't overload the notion of the existence of the member with whether the inner template, which is the massive one, fails to build.
Yeah, that sounds like an awesome trick.
And the other thing is that the static for each mixins are a great idea, but you can also just extract your common expressions outside of the static for each loop into an alias or a function and call that. But it's a bit annoying to pass all of the scope into that. But
yeah, thank you very much. I didn't create PEG, but I ended up as its maintainer. And it's by no means perfect, but it's a very interesting project. And I'd like to hear your opinion on two of its features. The first one is memorization, which, as I understand it, is central to, in theory, make the PEG grammars be parsable in linear time. But in practice, if you turn on memorization in PEG, it probably, depending on the grammar and the input, it can be slower than without memorization. Do you have any ideas about that?
I don't know that I actually used PEG'd at all. I used it as inspiration. Yeah, so I know very little about the implementation of it.
But you don't use memorization in your...
in my implementation, no.
No. So you might not need it at all. And the other feature is some PEG grammars can be left recursive, meaning that it can send a naive implementation of the parser generator into an infinite loop. And PEG has, since 2017, has a way to break out of those and support left recursive grammars.
I probably would get in an infinite loop there.
Yeah, yeah. So if you'd like to know how to break out of it, 2017 there's a DConf presentation on it. Thank you.
I'll just quickly check the internet to see if we have a question. We do not. So do we have one last good question here to wrap things up? Should I just skip to asking for a bad question? No, we've got one here. And another one.
Just a very short one. When you do these declarative grammar specifications or syntax UDA, are recursive rules allowed at all?
Yes, probably with the caveats that there's probably cases where you would hit a Stack Overflow, depending on exactly how things are ordered.
So
the S expression grammar I showed is recursive, right? You can nest an S expression inside of an S expression, and that does work fine.
Okay.
Nice talk. Is it possible to have the presenter mode 6 years ago in Linux?
Yeah, unfortunately not.
Well, let's call that done. Thank you, Ben. All right, so that concludes the morning part of this. Lunch downstairs, as you all know. We'll be back. English, I've lost my ability and my voice. We will be back here at 1:30, where Timon will have an announcement. And then directly after that, we will have lightning talks. So eat, be merry, and be back here for 1:30, please. All right, we all back from lunch? Probably not. There's probably still a few stragglers downstairs. You did yell loud again, didn't you, Nicholas? Yeah? Yeah, no, we heard it on the internet. He was loud in Australian, so if they didn't hear that, it's on them. All right, well, before we get into the lightning talks, speaking of that, actually, Murilo, Robert, Bruce, Dennis, Stephen, Ben, Amory, and Karsten, probably best if you go line up over there, waiting to do your lightning talks, please, so we're not getting people bouncing back and forth through the audience. You've got a question? Is there anything that can be done about the flickering fluorescent over there? Sit somewhere else. Yeah. Well, they'll sort something out and they'll let you know. But meanwhile, we do have a show to go on, as they say. Yeah, Timon here, you have some announcements to make, don't you?
Last year we had a little competition that was called Phobos Golf. So the rules are repeated here. So basically there were those 8 tasks and people had to find the most succinct solutions. There were some special rules about scoring so that you can use long identifiers from Phobos without incurring a lot of costs. So the costs are just characters. And here's the table where you can see who last year most successfully forwent all of the opportunities for networking and alone in the room optimized the solutions the most efficiently. And the winner was Dennis. I'd like to quickly show some of the submissions that we got. So this is the square task, and the goal was just, well, you get an integer, print it square, do it as succinctly as possible. Here are the best solutions over time. So only correct solutions are shown, and only solutions are shown that improve the previous best score. So each of those were the best scores at the time. So this was the first correct solution that scored 18. This is what you would probably do if you just had to write this code. Then Dennis improved on this by using a little known feature called property assignment. So he saved 1 token here, right? Instead of parents, he used an equal sign. Then Razvan improved on this even further because instead of too long, you can just use big int. This is another little known feature. You can just use a constructor in UFCS. And then Dennis improved on this again. I mean, he basically combined the previous two insights, except he found a different way to do strip.bigint. It's not a big int, but he used parse JSON because it turns out an integer is actually valid JSON. And JSON is naturally white space insensitive, so you don't have to strip. Then there's a similar task. We have to just add 2 numbers. So you have the obvious solution, and then after all the tricks, it looks similar, right? But this one is quite readable, except maybe that the big int is a bit overkill. Then we have FISPAS, the first submission again from Guillaume, the first correct one, I mean, and it looks kind of uncontroversial. Then we have some submissions that improve on this. Some of them are even more readable than previous submissions, even though they get better scores. This is one of the submissions from Dennis that I really like. So he adds basically a comment here because he wants a lot of empty lines. And why does he do that? Well, we had to iterate from 0 to 100. So he just put this for each. Put it on line 100, and so you could use the line token, which only costs 1 instead of 3, as the 100 literal is costing. Then Rasman did a nice submission here that is also quite short. I have a similar one. I won't go in detail over all the improvements now. But this is another improvement by Dennis, which again uses the same trick. This is not an improvement, but it also works. Then he actually got something that's quite readable again, and he actually got rid of the line trick. He can just use a character literal that also evaluates to 100. And this is the winning submission, and I think it's quite elegant. All right, so I will skip some of them so I don't use too much time, but I would like to show the calendar task. The goal was basically to reproduce the outputs of the calendar command. And it took quite a while for Dennis to get this, because there's actually a special year, like 1752, where there's a switch from the Julian to the Gregorian calendar. So there is 1 month that has a lot fewer days. And you can see he gradually improved on this. And we can actually, maybe let's look here and just look at the big improvements. So this is already too far. Let's, oops. Yeah, I mean, I zoomed out already. Okay, so this is the last submission that kind of looks like it should. And then he had an insight that he can actually exploit the scoring system, because identifiers are quite cheap. So basically, you can define an opt-dispatch and then just use the string as a string literal, and then you can encode your entire code inside a single identifier. And I mean, it's not constant cost, but it's it was cheaper. And the thing that I really like about this, it was cheaper by exactly 1. And he kept improving this. And I think here in the end, he started noticing that, like very short identifiers actually grow in costs less quickly. So he split them up into multiple identifiers, and he called opt-dispatch for each of those using a with statement. And then the final submission is just doing this consistently for the entire code. Yeah, so I think this was really clever, and don't try this at home. All right, thanks. So that's it.
All right, so now that means it's time for lightning talks. First of all, we'll get Murilo to come up and plug in. And the way these talks work is that the speaker has 5 minutes. It's on the timer here. I'll let them know when they have 1 minute remaining, and then when they're out of time, you get the gong, that's it. Then you'll get the opportunity for 1 question from the crowd while the next person plugs in. So we're all familiar with the format, I think, or most of us are. So, Murilo, it's your turn. It's our first lightning speaker. You guys looking forward to these? You still on a food coma from lunch? Yeah, a little bit. That's fine. It's taken a little while. Here we go, finally. Cool. Plug in. We're operating off the lectern microphone here. So no need to wire up everybody this year like we have been doing. It's probably good that this is the first one, because we try to make them quick between each talk. So. There we go. Sounds like you're good to go. All right. Then in that case, your time starts now.
All right, everybody. Thank you for having me here again. I'm going to have to be quick. So I'm going to talk about comparing the lang to other languages from a pragmatic approach. C is a super fast language, right? It was designed to be like that, but it is very minimalist, right? It doesn't have object-oriented features. It's not practical to use. Python, on the other hand, is super powerful. It has everything, you can do everything easily, but it is still slow. It can be more than 400 times slower than the other languages, such as C or D or C++. D, on the other hand, is both super fast and super powerful, and it is easy too. So here comes the question: why isn't everybody using D for everything? Right? If it is something so good, why isn't everybody using it? Could it maybe be the lack of marketing? Because unfortunately, more and more I discover many people out there don't even know D language even exists. People have told me once when I wrote about the language D, they said that they thought I had accidentally typed the letter D instead of something else. They only later discovered there is a language called D. And I think maybe one of the reasons why so many people don't know it exists, maybe this is what is causing so many people never to care to check it, to try to learn it. I've been trying to raise awareness about the D language by going everywhere I can go and give a talk about the different things, but I always mention the language D, or often I give a talk which is all about that. For example, here there was it was an event for the technology, and I was giving a talk about how to implement AI, and I did it all in D in front of the students, and I encouraged them to try this language. Here there was another event in which I spent the whole afternoon talking about all sorts of things, and I would also try to tell everybody how fun D is. And this is another event. It's called the Campus Party Brazil event. I was there, and I was teaching people how to make multimedia software using the D programming language. The Facebook group now has 670 or 680 people, which is a good number of people. It was the Facebook I had created years ago. But I still wish we could see more activity there. We only get like 2 or 3 posts per month, not that much activity, unfortunately. Now the question is, where is the D language community? I have been searching for you guys on Facebook, groups, Facebook pages, Instagram, YouTube, Twitter, and guess what I have found? Nothing. I think there is only the Twitter group of the D Language Foundation, and I don't think there is anything else apart from that. There is the forum on the website, on the dlang.org website. It is fine, but it is something that first, it is too restricted. People only enter it when they are already members of the community. And it is not something very attractive, because if the guy is still learning and he figures he's going to be forced to enter that forum every time he has a question to ask, this is something which kind of pushes people away, because they prefer to be part of a big Facebook group where they get their questions and answered faster. My first advice is do more aggressive marketing. People need to know what is out there, and that takes social media communication. So you could create more Facebook, Twitter, and Instagram pages out there. And my second advice is reach out to the youth, the newbies, the students, people who are learning. They are the ones who will be more interested in a new, easier language. And my final words, never miss an opportunity to show your friends how awesome the D language is. And this is it. Thank you very much.
Am I allowed to gong anyway? All right, thank you, Unplug, and we'll take a question from the audience. Yeah, Unplug. Robert, you're up next.
There's a comment, really. There's a Discord group, which is actually pretty cool.
You might need to repeat that.
I'm sorry, because I was focused here. I did not hear. Can you please repeat?
It's a comment, really. There's a Discord group, which is pretty cool.
Oh, really? Discord? Ah, yes, I remember. I used to be a member of that, but it has been so long since the last time I used Discord. I had almost forgotten about it, but I know about it. Yeah. But thanks for reminding me. I have to go check it again. Thanks.
Okay, thank you, Marino. Applause. All right, next up, a lightning talk about why you should come to DConf to the people who came to DConf. All right, well, your time starts now.
So yeah, this is going to be a quick one. Why you should come to DConf? Like the only actually important things how to distinguish languages are those two. It's justifiable and unjustifiable. What does it mean? On the justifiable side, if your project succeeds, it's okay, nobody's going to complain. If you fail, nobody's going to complain. On the unjustifiable side, if you succeed, everybody says it's going to be a fluke, you can't repeat that, who cares? If you fail, it is because you chose that language. And then there's this group here. What is over here? Like if you come to DConf, you will never be asked, like, why are you doing this? There's always going to be somebody who said, that is interesting. And now for the actual audience at home, when you are watching this, you are a person who's watching lightning talks at DConf anyway. You're so far down the rabbit hole, you are here already. Just buy the ticket and come. So part one, and you get an extra talk. The extra talk is why you should give a presentation at DConf. And that one is even quicker. It will change your life. It did mine. I know it changed other people's lives, and I'm not joking. Just come, give a presentation. I remember my first presentation, like 10 minutes before, back in 2013, I realized that if there's ever a crowd that can destroy me publicly for all eternity, recorded to YouTube, it is this group here. It didn't. Like the day after that, I was talking at the first day. The day after, Andre merged my first pull request to Phobos, and that has been 12 years ago. So it will definitely change yours as well. So give a presentation at DConf. That's it. You can go on. Maybe I get 2 questions. I'm quick.
Yeah, maybe new rule. If you finish that early, you can gong yourself. All right, yes, unplug. Sorry, who did we have next? We had Bruce up next. So, Bruce, come on up and let's take a question from the audience.
Everybody convinced?
Yeah, I think you convinced everyone. But maybe somebody should give a testimonial then instead of a question. Here we go.
I mean, I was sort of coerced to give them a talk at DConf. And apparently this is how I was contacted by the Weka guys and ended up landing my job. So yeah, it changed my life.
Oh, it changed his life too. Here we go.
Yeah, my whole career is like backed by the fact that I came and gave these talks.
Example by 2. It must be true.
All right, I suspect we'll be here all day if we let that continue. So thank you again, Robert.
DConf speaker slots are reimbursed, so if you're a poor student, it's a good gig.
There you go, financial incentive, get on it.
Yes.
All right, so we got Bruce ready to go. You got anything else to say, Nicholas?
Yeah, I'm giving part of the talk because
Nick's the lead in here.
Oh, all right.
I'm the front man here.
Okay, well, I'll leave you guys to it. Kick the timer off, off you go.
Yeah, so dcompute is a sort of compiler extension and set of libraries to run decode on the GPU. It's a restricted subset. It's supported OpenCL and CUDA for some time, but together with Bruce, I'm working on getting Vulkan Compute to run. We've just had support in LLVM, like this last LLVM 21. There's still a bit of feature development yet to go. This is some example code that I'm working on that actually compiles. And if we can figure out where the other, it produces, double click.
It's this one right here.
Yeah. It does produce some LLVM. I don't have hardware to run this at the moment, but yeah, we're doing a sort of a wrapped kernel because graphics things are weird and are not like the compute stuff. So we're only doing compute shaders at the moment. But if I can steal some of Mike Shah's students to do some graphics at some point, that may change. And I'm going to hand it over to Bruce to talk about what he's been doing with the runtime side of things.
Okay, so turns out that you need a runtime to assist decompute. Mostly it's about launching kernels. Launching is just a term to, say, activate or call a piece of code on the GPU, which is typically denoted as a kernel. Hello. Let's see if I can get it to the next tab. There we go, yeah. Okay. So there's some reasons for why you might want to use decompute. And it's expanding the reach of, competitive reach of deprogrammers. You need to use a GPU if you want to be ultra serious about gaming or HPC or AI. Or this is John's favorite, if you want to write way faster spreadsheets, you can use it, yeah. Okay, the GPU performance possibilities are pretty significant. It's typical you'll get 3x plus better performance per watt. Depends on the algorithm and things you're doing, but just generally you're working with memory that's closer in and burns a lot less power. There's huge shared memory bandwidth. Even the weenie phones come in at hundreds of gigabytes per second in bandwidth that's available. And of course, the larger GPUs get up to the terabyte range. There's teraflops. Not too many people are interested in flops so much as I think as memory bandwidth nowadays. D has some edges here, or an edge. Metaprogramming is better. Nested functions work out particularly well, and it's not C++. Okay. One of the goals here, a big one, was to have near universal deployability. You wanted to have, to be able to get out to the entire world. And Vulkan, at this stage that we need it, is out there at 93, 94% of the GPUs that are shipping nowadays. Okay, I'm going to have to skip ahead here. There's a fat binary approach where what we do is we produce multiple sphere Vs and you select amongst them at JIT time to target the particular GPU that you're on. So if you have some wider subgroups or you have particular matrix multiply extensions or things like that, you can deploy a bundle of kernels. You can deploy a bundle of kernels and select amongst them at JIT time. Yeah, I'm going to keep going here. Forget that. Okay, here's some cautions. It's pretty much a base D only environment. It's inherently async. It has a weaker memory consistency model. There's still work to do before it's ready for prime time. The launch latencies, this is a thing where you want to say CPU or GPU. And if you want ultra low latency, you're probably talking about a CPU unless you have a ton of work to do. Launch latencies are 2 microseconds to about 50 microseconds overhead. Got it. Okay, and here's some work to do. We're going to tie into the to decompute the backend LLVM. We're going to go to a push constant arg for passing for latency reduction. This is better than what the other people are doing. The other shaders, task graph abstraction, and some defaulting for the mono CPU case, which is common. And we need another better name. So if you got one, we're all ears. That's it.
Well, you finished early, so would you like to gong yourself off?
I think Nick's
going to gong it off. Give it up for the both of them. All right, Dennis, you're up next. Well, let's take a question from the audience. Down there, Timon. Bruce, you'll need this.
Thanks.
Very impressive and important work. Thank you very much. So I was just wondering, in what way are the fragment and vertex and geometry shaders different from the compute shaders in terms of implementation?
They have extra special, wonderful ABIs. There are quite a few similarities. The main thing is how you marshal and pass arguments, and there's a kind of reflecting of the history of how these other types of shaders came about, there's more of a fixed pipeline feel to it. You can't just say, well, here's the memory, do it. Instead, you have to say, this is a one of these, or this is a one of those. And so you have this kind of funky fixed pipeline setup, which is a legacy deal. But Nick has assured me that he can do it in a weekend. It's not a problem.
There's also the problem of LLVM support, which I don't think they quite support.
I see, that makes sense.
Stuff yet, but
yeah, it's close. I mean, it seems doable. It's malleable. It's at the right interface level. I think we'll get there.
All right, thank you again. Yes. And keep applauding for Dennis. 5 minutes, starting now.
Right, I'm going to talk about my D game for the GMTK Game Jam, an annual game jam where you have to create a game in 4 days or 2 days earlier with a specific theme. And me and 2 friends have been doing this for 5 years now using the Godot game engine. And these were the past themes, and there's our submissions made in Godot. You can find them at subdomain.itch.io if you want to play them. And after, like, I felt like we were kind of stagnating, and Godot, I got kind of tired of it. There's some, I don't like the language, the GD script, which is basically Python, and I don't think the D bindings work for web exports, which is very important for the game jam because you want all the people to be able to quickly test it, and they don't want to install your game and stuff. Since the beginning, I was fiddling with the physics, just trying to get a pendulum or like a chain to work, that it would get all unstable. And even last year, the theme was built to scale, and the Godot physics engine doesn't support dynamic scaling, so everyone had to hack around that was using the engine. So I felt like the engine is just half of the time getting in your way instead of accelerating your game. Another thing is it's pretty bloated. The engine itself is 1 million lines, and an empty game exported is already 40 megabytes of WebAssembly, and every time you load a game, usually there's a loading bar, and I'm like, why? Like, these are simple games. So hear me out. Don't throw me out of the conference yet. I started suggesting let's use Rust. Like, my friends use professionally Python and Java, and for hobby Rust, and I'm like the D guy. But I was like, well, let's use Rust. Try to get away from Godot, and we saw this article, but the second on the list is MacroQuad, which has simple shapes, simple code. But the example they gave is just drawing a rectangle. Like, if that's your poster child, like that's your showcase of the engine, you're kind of like, wow, I drew a rectangle in Rust. But the flagship engine, ironically, by the way, Godot has trouble. Like, it's pretty hard to draw a rectangle in Godot. So next, we were looking at their flagship Bevy engine. And yeah, it's supposed to be simple and data-driven and productive with compile times. The first compile took 45 minutes, though, on my friend's old laptop. And as a joke, I wanted to build it during the entirety of this lightning talk, but when I install it today, there's just all these warnings, and I can't even find the error anymore. It's just drowned out by warnings, which also goes back to my last talk. Let me see if I can quickly, oh yeah, there's the error. And then it continues to build 456 crates it depends on. And so yeah, you don't want 30 minutes left and still have to do a clean build, but you might think, why can't you just incrementally build? Well, the Z editor my friend was using, the AI assistant helpfully ran cargo clean after the so he had to recompile everything anyway. And also just the code, it didn't make us look happy, so now comes the devious plan. After giving them a taste of Rust, why not use D? I want to say, I don't like tribalism. I don't want to bash on Godot and Rust. I love open source projects. But yeah, in this case, I suggested using D. Since WebAssembly has been added to LDC, I've been dabbling with it and written my own JavaScript things. It's not ready for a game jam yet, so my friends gave me a wish list of things they wanted me to code in D before the jam started, because you have only 4 days and you don't, going from scratch can be pretty hard. Created a NixOS file to quickly install dependencies, and that was pretty useful. Yeah, I don't have much time, so I'll very quickly go over the tech stack.
1 minute.
All right. yeah, I use my translations of GLFW and libsound.io for Linux and Windows, windowing or sound and graphics, OpenGL, simple bindings, some JavaScript glue code, my own simple collision code. It's all very few lines. I wanted to keep it very simple. My game data structures also, I wanted them to be very simple also because my friends aren't D programmers, so I wanted something familiar and not some fancy struct mix-in based entity component system. So yeah, for assets, I also used some found some libraries with very simple formats. And there were, of course, still some issues using D, getting an editor working. Oh, really out of time. Well, let's skip just. I was also using, there were some logistic issues with my desk being a cardboard box because we didn't have space. So I'll just let the game run while we have questions.
Stephen, come up and get ready. Dennis, unplug. Audience, let's have a question.
Very quickly, just showing how quickly they load. And there it is.
That's not how this works. Unplug. Unplug.
All right.
So it's a comment, really. Every time you'd speak to someone that's using Rust or C++, and you keep agreeing with them that using Rust and C++ is good, and then you tell them about D, and then you say, keep using Rust and C++, they get very confused and get very curious as well.
Well, thank you again, Dennis. And hey, we all know this guy, Stephen. Look at him. Applaud him. And your timer starts now. Go for it.
All right, so I said after last year I would never give another GC talk again, but you guys insisted, so damn it, here I am. This is just to show where the new GC is. This is a post from Mathis from earlier this year saying they tried the new GC at Funkwork and it made a huge difference in some very high memory using programs. So the new GC is generally available since July. This is kind of the support matrix of what can use it right now. The ARM support is pretty much brand new, although it was only like a couple lines to change. And because of that, the pre-built image does not include SymGC, but you still need to use this compiler because there are some pieces that are not yet released. You can notice that you need to use DMD master or when 2.112 comes out in order to properly use it. Kind of a few things that don't work that I could think of. The GC profiling printout at the end, that's probably pretty easy to add, but I haven't done it yet. There is a bug, kind of. It's hard to explain, but the way that signals and slots work is they tack on pieces of memory to the object monitor, and then when they do that, if the object is not set up with a finalizer, it switches the memory to saying, oh, this has a finalizer. That just won't work in the new GC, to just add a finalizer when there wasn't one there. So so right now we can't support that. There's thoughts on how to do that. Same thing with monitor destruction. So if you synchronize on an object that doesn't have a destructor, that monitor is going to be not cleaned up when it gets destroyed. Performance is really good for memory performance. We get usually about 50% memory savings in our internal projects. Single-threaded performance can be a bit slower. That part of that is the aggressive handing back of memory to the OS, and that can be tuned probably. Multi-threaded performance is scaling much better than the old GC. I'm going to show that in a little demo here. And Bruce and I are working on a SIMD-based scanner so that we can scan pieces of it much faster. So let me just show you a quick demo here. This is a program that essentially uses std.json to, if I can highlight it, it's std.json to load a big JSON file. If I do generate. Oh, I'm in the wrong directory. Oh, that's right, because I'm on a VM, because there is no support on Mac for this, unfortunately. Okay. So this is the JSON file. You can tell it's a lot of lines of JSON. It's about 60 or 70 megabytes. So I'm loading that 5 times and throwing it away. Of course, you know what happens when you load a JSON file with SU.JSON. It builds a giant structure of everything. And so I have an option here. By default, it just runs it in one thread. Otherwise, you can pass an argument saying run in multiple threads. So let's try it out. I've already built it, so let's just, this is built
1 minute.
Mode. So let's just do that. And this is, oh, let me just, what did I do here? I got to do it with a, so we can get some stats on this. So, and this is with LDC, so it should be pretty well optimized. Yeah, it should be optimized. So this takes about 4 seconds to do on one thread, and it uses about 1 gig of RAM. And if I do this with the new GC, it's going to take longer because the performance isn't as good with the memory, but it does use a lot less RAM, so only 356 megabytes. And if we run it with multiple threads, the time should be roughly similar. And if you run it with the old GC,
Come on, you've been gonged.
all right.
See how these
Try
work.
it.
We got to get you through quick.
Try
So applaud. Well, you've already applauded. Hold on. Come here for a question. Question from the audience. Ben, you're up next. So come plug in.
Yo, so when is this going to be in official releases?
Hopefully soon. I definitely have to get it working on macOS and FreeBSD, all the platforms we support, and the goal is to have it at least be the default when it makes sense. But other than that, it'll be a selectable piece, kind of like the conservative or the precise GC.
Thank you again, Stephen. Hey, you're tenacious. You've already had a talk today.
Coming back for more.
Cool. Well, you got 5 minutes again. So let's hit it.
I think
Am I going?
this is going to be really short, probably. So D is the best language, but sometimes you have to use other stuff. And in particular, I have been using Kotlin and Swift for various projects. Kotlin because I teach a class on Android, and Swift because I do Apple stuff sometimes. And the modern UI code in both of those languages looks something like this, which might look like it's some sort of crazy DSL for, I don't know, it's like I turned code into JSON or something. But that's actually not what's going on here. All of the things with curly braces after them are actually just normal functions, sort of. It's just that they have kind of a cool syntactic sugar feature, which is that if the last parameter to a function is a function, then instead of defining your lambda inside of parentheses, you can stick it in the curly braces after the end of the parentheses. And so it looks like a JSON structure, but it's really just passing a function to a function. And so I think the code looks pretty nice. They also, like D, this is like the one case where they let you drop empty parens. So you can just have like row curly braces. And it looks like a sort of a JSON-y structure, but it's really just nested function calls. So it's not just for the UI framework. They use it for all of the functional type things. So in map, you can say map curly braces and then your lambda. So is it worth stealing for D? Maybe, maybe not. Some things that make it work nice in those two languages is their lambda parameter lists go inside of the curly braces. So you naturally say curly brace, param, arrow, whatever. However, in Kotlin, if you only have one parameter. It can be implicitly declared as it, so you don't need a parameter list in that case. So if we did something like that, maybe it would look nice in D. Another potential issue with stealing this for D is that a lot of the lambdas that I pass are template parameters, not runtime parameters. So I don't know how you would decide which curly bracket thing is allowed to go there. But yeah, I think this makes APIs that use a lot of lambdas slightly nicer. So here we have an example where I'm returning, I'm storing a reference to a value in a slice. And when I append, I get a dangling reference. An API that explicitly has like an update method, which gives you the current value and lets you update it in like a functional way. Means that your lifetimes are tied to the lambda scope, so you can't have these sorts of dangling references. So it's kind of a nice thing to encourage more functional style APIs. So I'm not going to write a dip for this, not necessarily even advocating for it, but it is a cool thing that I've seen in other languages that I have to use, and figured it was worth sharing. That's all I got.
Well, you finished early, so you got to gong yourself off. Louder! Hey! All right, I'm already you're up next, and audience, let's have a question. Really? Come on. Well, I'll tell you what, we're not going to have the bad joke session today, so how about a bad joke? Does anybody in the audience have a bad joke? He has a question, good. Circle back to the bad joke later.
What was your, like, you're saying, oh, nice things to borrow. What's something that you really missed about D when you're writing in, like, Kotlin or Swift? What's the biggest thing that makes you like,
Swift, I think, is confusing because it's kind of more of an ML background, so it's just a big change for me. I actually quite like Kotlin. I don't have a lot of shit to say about Kotlin.
All right, well, thank you again.
Do you have a mic or do you speak?
Yeah, you're on the lectern, Mike. You're not going to do a GC talk as well, are you?
No.
No, all right. Well, you got 5 minutes to talk about this, so let's kick it off.
All right, so I'm going to talk about SDFMT, which is a formatter for D. It's the snazzy D formatter. All right, what the fuck is going on? But first, I want a round of applause for Cyber Shadow, who is in the room, I think, who designed our snazzy D man here, which is very snazzy. And all right, so SDFMT. It's a code formatter for D. It's built using SDC as a library. It's used today in production, at least in one company. It uses a custom parser because, like, the general D parser is, if you parse into an AST, you have a lot of problem with comments and stuff like that. When you want to format, it doesn't retain all the information that you want easily. The way it works is that it explores various possible formatting to fit your code on the page. And each of them, it attributes a score, and it's going to keep the one with the best score. SDFMT itself is formatted using SDFMT. Obviously, it's your own dog food, right? Why do you want to do that? Well, you want to avoid useless round trip during code review, right? Like, oh, this is not the style of the project. You need to indent this and do what, like all of that. Just run the formatter and all this kind of issue go away. You want to make good code look good. You want to make bad code look bad. And everybody's code looks consistent. And you want to avoid debate. So as a design decision, there are not a lot of options and not a lot of configuration, so that you don't have these giant debates or like, do you want the curly brace like this or like that? And quite frankly, it's good that it's all consistent and every single of those styles is like pretty much equivalent, as long as it's always the same in the project. So some example of what it looks like, you can see that, it can split long expression that wouldn't fit on the line. It's good enough to indent stuff differently when they are at different priority levels. So, if you have different operator precedents or whatnot, it's going to do the right thing. another example is like if it splits, long list of stuff, it's smart enough. You see that the inner one, it does bin packing, and the outer one, because it did bin packing on the inner array, the outer array, it explodes it completely. It's smart enough. Like there is a lot of small stuff like that you don't quite realize, but it's actually quite important. People expect their code to be formatted in that way. And obviously there is always the question of like, what do I do if I don't want my code to be formatted because somewhere I have like a specific formatting to convey something? Well, you have magic command to disable the formatting on some section of your code. And it's an example. Here we go. So to wrap it up, explore different solutions to format your code. Keep the cheapest one. Stops when the code fits on the page, because the solution space is actually very, very, very huge and combinatorial in nature. You have to use pretty fancy programming techniques to be able to explore it efficiently. So we use dynamic programming and we cache like subsection on the formatting and all of that. Doesn't really matter. So what matters is how do you use it? Well, you have the commands there. You clone the project, you make it, and then you can use it, right? It's as simple as this. Also, it's on dub thanks to Max, who, I don't know, I don't see him, but he was there yesterday, so no, he's not there today. Well, here we go. But yeah, if you want to use it, you have the command. Very easy, very good, and that's it.
Louder, come on. That's better. All right, Carsten, come on up, and we need an audience question. Oh, we do have one right here.
Is there a reason you opt for format off, on, and not have an option to just disable the formatting inside the scope?
Can you repeat? I'm not sure I understand.
Yeah, in the example you showed, you're basically turning off the formatting for a section and then turning it back on. Wouldn't it be nice if there would have been an option to just disable formatting until the end of the scope? Because these are most of the cases that you'd like to disable it.
Yeah, I mean, it's actually probably a good feature to have, but we don't have it.
All right, well, thank you again, Amaury. And we have our last lightning talk here.
Yeah. So
good to go?
We can we see it? Okay.
You can also look at your monitor down here. It's probably a bit easier.
Okay. Yeah.
Well, the timer started, so I guess you're going.
Yeah. Okay. So we are doing a little with WebAssembler because we are doing a platform-independent execution. So WebAssembler is a good platform for that. And we have implemented WASM to better see. It has an advantage because we can look at the code and so on. So yeah, that's very nice. We can't see what I'm doing. Maybe I can just, no. Okay, so WASM is actually, it's a stack-based machine, and it's both stack and register because it has local registers, but it's in principle all instructions are stack-based. So it's so this one is actually how it looks. If I can show it here, this is how it looks in a format, in text format, because WASM is a binary format, but in a text format it's via WASM AST. So it's actually easy to pass in a text format, and then you can actually convert it to a binary format. So we have an example here where you have converted this one to, if you can see it, this one to a better C function. And then I would like to, yeah, so what you actually have, it's very, very bad here, right? So what you have in the WASM, you have block-oriented structures. So everything is blocks instead of in normal assemblies it's jumps. So everything is blocks. So you have a block inside a block. So all blocks are actually type checked. So you rewind your stack to match this. So you have a simple block. So you have a loop block, it's just a simple block, and then you have an if else, and then you have branches. So you have unconditional branch, if branch, and table branch. So that's actually it. And then, of course, you have calls and indirect calls. So if I can show, yeah, okay. This is not very smart, but you can see this one is actually the table. Yeah, we'll just try to switch screen actually, see if I can do this. Can I do this? No. Okay. Maybe. Does it work? No. Okay, I'll try this one. No? Okay. So I would actually like to show the program, but this is, of course, not working. How can I do this? Okay. So, what do I have? Okay. So, oh. So if we have, for instance, we have a WASM file here, we can display it as a WASM
1 minute.
1 minute, and then I can just say, okay, I want a D file, and then I can say, okay, how does this D file look? It looks like a D file. So that's it. Yeah. So you can compile this. Yeah. So that's it.
Finished. Well, you got to gong yourself off.
Yeah.
That'll do, that'll do. All right, we got the question over there.
So this is a WASM to BetterC compiler. Is it available?
Yeah, but not in this version. It is available, but not the latest version. But it's actually a tool. It's a more general tool. You can take. You can actually also use it. You can take WASM and dump it as a binary, convert it into what's called a VAT style, and then you can take a VAST style and convert it into a binary, and then you can take a binary and convert it into BetterC. So it's more like a tool for general, and it's actually also a library to. I have a range which can run to a binary, and you can also build a binary, and so it's more like a. But it will be available in a better version later on.
All right. Well, thank you again. And yeah, this is a special request for me. You can hear my voice is getting pretty close to cactus again. I need to relieve this pain by gonging off a bad joke. So somebody please tell a bad joke. It's tradition now. For the last 2 lightning talks at DConf, we've had those bad joke sessions. I need to gong a bad joke. Who's got a bad joke? Raise your hand. Anyone? No one? You gonna let me sit here in pain? Ah. I can't believe you lot. Oh, here we go. We've got 2 hands now. Let's go for 2 bad jokes if we can.
I mean, I wish I could turn this into a joke, but I was Mike Parker recommended me to go to the Battersea power station, and I thought it was pretty funny that they named an historical London building after a D feature.
Battersea. Yes, all right. That's worthy.
Why did the demon go to the cemetery? He wanted to see some dead languages.
Thank you. All right, yeah, I do feel better after that. Thank you. We're back here at 2:45 for the next talk, so you have 20 minutes to not tell bad jokes. Tell some good ones to yourselves. All right, we all here, we all paying attention? You need to pay attention now because my voice is basically cactus. It's going. But hey, good news. We got another first-time DConf presenter. So, Ludovic, let's take it away.
Thank you. Hello and welcome. My name is Ludovic Lucenic, and I came here today to share my experience with the D language and its ecosystem as part of my effort to build an efficient software development and runtime environment called Arina's platform. I first came across the D language back in 2011 or 12. And after some studying and prototyping, I started using it for Arina's platform around Christmas 2013. But let's start from the beginning. Yet I would like to ask you one thing. Look at everything I show you just as one possibility. Don't focus on individual details or representations or visualizations, but rather try to see the idea behind it, the architectural paradigm. My wise wife gave me a very simple and profound piece of advice for this presentation. Go straight to the point. Those married knows how does it feel. So after a considerable amount of painful brain twisting, I finally figured out that the most comprehensible way to deliver my message today is to focus on one thing: efficiency. There are two perspectives on efficiency, computational and system efficiency. This is where the D language truly excels. And software development process efficiency. And this is where Arina's platform, together with its LESS language, comes in, both of which I'll show you today. Software development, a craft, a skill, an art, a bit of each, I'd say, but above all, it might be our attempt to tame the unpredictability of the world around us. So what might be one of the approaches to deal with this unpredictability, considering that we cannot deny the economic aspects of our lives? For example, the limited time that we'll all ultimately have. To focus on the process, and for this process to be highly efficient, to say the least. As engineers, when we focus on the efficiency of our process, we naturally start asking, how do we measure it? The usual answer is by costs. That can be either financial, time, or in terms of missed opportunities. And what costs us the most? In my experience, it is uncertainty, which can pretty much be another word for every if is a buck. What is the cause of uncertainty? It is called entropy, an intrinsic property of our world. So how does entropy manifest itself? As complexity. Now, how do we usually approach complexity in software design and development? We use models, decompositions, abstractions, and higher level concepts such as software architecture. If we ask further, what does it mean for software architecture to be efficient from the process point of view? We might agree that it is the ability to answer architectural questions quickly and consistently. What enables that then? Software architecture that is visible. It means that documentation and code clearly indicate the precise place where to make modifications, enabling efficient implementation of the requested changes and the new features. If you cannot answer this or cannot do it quickly, then the visibility of the architecture is not sufficient, at least from the process efficiency standpoint. Now we focus on the process efficiency, and for that it helps greatly if the architecture is visible. But what is software architecture? It is a set of concepts and features embodied in components, their relationships, and principles and guidelines that govern their design and evolution. And it is also a set of or summary of design decisions that shape systems structure and guide all other design work. I can hear some of you saying, what nonsense, all this abstract talk. So let's make it a bit more tangible. Imagine our system as a city with roads as data flows, districts as domains, traffic lights, for example, as control flow, and all buildings as components. To see the architecture of our city is like having its city map. If the map is clear and correct, our decisions can be effective and fast. Arina's platform's approach makes this map clear. Arina's platform is a tree-structured runtime development and runtime environment. It helps developers and architects build software consistently, both bottom-up from components and top-down from architecture. It represents all structures as trees, where the runtime interprets a program by traversing its architecture as a tree. The main premise of this paradigm is that control flow traverses an acyclic graph. This makes components responsibility boundaries explicit, which in turn enables effective reuse and easier refactoring. Achieving these ambitious goals requires extensive tree manipulations. The LESS language addresses this need. It is an interpreted language used effectively both for defining program structure as well as for expressing operational logic. Currently, the modules and the engine's entry point are based on an HTTP request response handling procedure, and adapting this entry point to other protocols could extend the approach to a great variety and numbers of software systems and solutions. Let's have a look at a tree. Why a tree as a symbol for this talk? A tree stands for structure, solid structure, and together with all the beetles and plants around it, it forms a lively ecosystem. And as has been recently shown, trees exchange information. This makes a tree not only an ideal analogy for information system structure, but also a fitting representation for building solid, dynamic, and efficient software. A program written for the Arina's platform starts with a program pattern. A program pattern is a tree-defining entry module instance, its attributes and subordinate patterns. These patterns then form the architectural layers of the solution. And they are defined in the same way. Here you can see an example of a pattern definition. As I've said, pattern has its module type, a set of attributes, and sub-patterns. This example is written in the LESS language notation. The same applies for every sub-pattern, since each of them is a pattern itself. So we can say a pattern is a tree with a specific structure or branches that can be executed. The execution of a pattern is determined by the definition of its module type. A module type is a structure, inversely, of which a pattern is an instance, that defines its type, location, which both comprises the spatial dimension of the Arenas platform paradigm. It has a parent module reference, the reference to its parent module type that implements object-oriented hierarchy, a set of attributes the patterns provide values for, a set of operations, and the hierarchical constraints of the sub-patterns that creates then the sub-patterning or pattern subordination dimension of the platform's paradigm. In addition to these public features, a module may also define private data and private patterns. Please keep in mind these three dimensions in which the modules are organized. Here you can see an example of a module definition. The spatial dimension here is implicit, since this snippet doesn't show the module's location. What we do see is its parent module type reference, as well as a branch reserved for defining allowed submodules. This way we specify which patterns can be subordinate under a pattern of this particular module type. The operations code is folded here for the sake of purity, but you can imagine to have it not only written in less code, but can be a D also, or other languages. And finally, what we have here is an example of modules operation implementation. All three examples are written in the same convenient notation of the less language. I'll go into more detail about the language, the less language later in this talk. For now, let me just show you how all the bits are all the pieces fit together and are organized visually in the Arenas platform's IDE in a browsable form. The Arenas platform IDE is a web application written in and for the Arenas platform. The blue part is for the module definitions, the yellow part is a program pattern, and the green is the editor. Modules are organized in packages with individual operations, and we can explore the program patterns down its architectural axis through various levels of the architecture, such as architectural layer, a component, element, or some individual function. The editor can be used to work with pattern definitions, module definitions, less language operations, and even other source code such as HTML, CSS, JavaScript, or SQL. The Arenas IDE makes it extremely convenient to switch seamlessly between coding and composition. These are the two buffers we move between when trying to manage entropy efficiently. Coding and composition are on the same axis of the entropy management. Let me now switch to a safe version of a live demonstration, where we begin with a showcase where we identify from the user's perspective the UI element our requirement refers to. We located in the architecture, and then we change its behavior accordingly. We may also show examples implementing requirements at various levels. And finally, I'll show you an instance of module reuse in practice. We have an investment portal where a demo account is available for the general public, and a back office operator can see which transactions are shown on these individual demo accounts. Every account has its own initial deposit chosen by the user at the registration. Our goal is to color the transaction type into green or red, depending on whether its value is positive or negative. The editor here shows the selected pattern representing the transaction type column. The Arenas IDE displays above it the chosen context as a path within the program's architecture. And the code, the highlighted code, responsible for rendering the column value depends on the chosen front-end component. We can now change the code accordingly in order to implement our requirement, which in turn is reflected in the application. If we wanted to change or color the whole row, depending or based on what modules we have, we would then choose slightly different approach and a corresponding level in the architecture. This example may require some time to explain, so I'll skip it for now, but if you're interested, we can return to it later. Or we might want it to show the account value for some specific time in past, for example, the end of last year. Then we would choose a corresponding element in the architecture as well. Or we could need to add CSV export functionality for every list form in the application globally, and that would also correspond to another element in the architecture. For each such a requirement, we would then choose corresponding approach and appropriate architectural level for the solution. To see the module reuse in practice, let's have a look at LS Code Online Editor application. There are a total of 3 instances of the code mirror editor in this application that is a playground for learning LS language. They render the input tree, the output tree, and the LS operation being interpreted in this playground application. As you can see, there is only one module definition patterned in 3 different contexts, each with its own set of values for editor label, editor default code, or rendering mode. All these examples show that every problem has its own natural level of software architecture where it is best solved, whether it is the top level of the architecture, a level of architectural layer, a component, an element, or a single function to be modified. Now, what makes Arenas platform truly unique is its language, designed specifically for tree manipulations and transformations. The full presentation of the LS language and all its capabilities is beyond the scope of this presentation. However, there is one key point to highlight. The language itself has no means of handling modularization. That task is handled by the platform. The less language serves only one purpose, transforming an input tree into an output tree. And this transformation may or may not depend on the platform state. The less language comprises basic control structures. The one interesting point may be the difference between for and for each. The former iterates through the direct nodes of a tree, while the latter iterates through its leaves. Beyond that, there are several ways how to open and access a subtree, to pass it around, and to assign values to nodes. Expressions in the less language are primarily based on those in D language. And for those interested, documentation or part of will be available soon after this talk, maybe tomorrow during the hackathon online. The Arenas platform is not by far the largest D project out there, but I hope it might become one of the more impactful ones thanks to the ideas behind it. Under the hood, there isn't much more than VibeD and VibeCore libraries, Z-shell interpreter, the compiler with its standard library Phobos, and optionally the Postgres database library for D. What may be more interesting is the process of developing this idea into reality. Building a platform like this is a bit like a construction project where you need to build the cranes and the scaffolding on the fly, even as you're already using them to construct the building itself. I believe the brave among you can dare to imagine what that feels like. It is similar to building a compiler for a language written in the very language the compiler is for. This is especially true for the Arenas platform IDE application, therefore the Ouroboros as a symbol for the platform. And now it's time to name the reasons why D was chosen for this particular implementation. There were a few fundamental values I was looking for when exploring the options: freedom, flexibility, and performance. Here is a list of strategic D features that it had and still has to offer. First, I wanted native compilation because the platform itself is interpreted. That ruled out some other alternatives like Java and Python right from the start. Second, I knew I wanted a tool that would let me manage the architectural layers and level of the platform implementation. Here, the multi-paradigm nature or menu of D came in very handy. Hand in hand with that comes the open source nature of the language and its ecosystem. In particular, I didn't want to implement my own web server and HTTP event loop, so the existing VibeD implementation was very promising. Finally, there had to be enough learning material and examples available. While limited to some extent, it turned out to be sufficient to get started. And I have to say that Andrei's book literally saved the day for me back then. After deciding to go with D, I discovered several other valuable features or advantages of the D language along the way. If I had to pick just one or two, I'd say metaprogramming is the real gem, but in the sense of putting code in mixins, so creating code that generates code. And I made great use of this feature. One very underrated feature of the language is its native boilerplate elimination. This simply cannot be praised enough. I want to write code that works, that does what I need, code that is self-describing, self-contained, concise, and without much hassle. I do not want to maintain code that only mimics all this boilerplate. While convenient, or while some IDEs can conveniently generate boilerplate for certain languages, it undoubtedly adds unnecessary maintenance complexity. How exactly did the D ecosystem help with the implementation of the Arenas platform? Aforementioned VibeD server laid foundation for the entire project. Runtime configuration reader relies on templated functions to do its job, and the most efficient implementation of the LAX3 data structure I could possibly imagine was achieved through various D features such as generic programming, compile time function evaluation, operator overriding, and more. In order to achieve seamless logging area segmentation, the Arenas platforms makes use of user-defined attributes that are then introspected in CTFE code. The implementation of the LESS language is a chapter of its own. I made highly efficient reuse of a DLEX implementation, which made it very easy to specify the rules and get it working. The extensibility of the built-ins in the LESS language, which is an interface from the interpreted language back to the compiled code written in POD, could not have been implemented so efficiently had the D language not be equipped with mixins. They're very handy, really. Besides all that, I have to say there was little I could not find on code dlang.io when I looked for it recently. And I think it is very good the D ecosystem has such a central repository. If I sum up the lessons learned while using D, I would say all the values are present. And it's not I don't regret it kind of a statement, but rather I wouldn't have chosen anything else one. It is solid foundation upon which anyone seeking the same values can confidently build. To point out some friction areas, I would say that the main obstacles I ran into were in the area of these advanced features and techniques, which, at least for me, lack reasonable documentation. I would really like the authors to provide more with examples, use cases, and comparisons so we can learn just enough to make informed professional decisions. Everything else on my list may easily or could easily stem from this single cause. However, two other things cause friction. First, because I need to make slight modifications to the VibeD, the life becomes complicated as this library is gradually split into smaller pieces, and instead of maintaining a single customized dependency, I now have to manage several overridden repositories as internal dependencies. The other issue is garbage collection, which is honestly something like mortgage insurance, something you don't want, but something necessary. I know there are ways how to eliminate it. However, when you don't do it right from the start, it becomes much harder once the system is in production. And using it efficiently stays or remains a bit of a mystery to me. The graph over there shows my server's RAM usage over roughly a month, triggering explicitly calling GC collect. While I can easily imagine the root cause here lies somewhere between my keyboard and the backrest, I haven't found garbage collection to be easy and it cares of itself solution. I'd like also to share some observation of the D community, or about the D community. I vividly remember watching almost breathlessly recordings of the DConf 2016 talks. I admired the presenters realizing what an extraordinary group of engineers they were. You are, we are. And how much there is I could learn. And this admiration for the people around D stayed with me even after more than 10 years working with the language. What do I enjoy the most? Definitely the spirit of open-minded innovation, the pragmatic approach, the sense of freedom I feel when working within the ecosystem. And last but not least, the hidden power that can be compared to driving a Porsche. Most of the time you don't need that much power, but when you do, it's right there. And I have to make a reflection on Louis' reason when he was saying about that he needs a tool that makes fun to work with, even after 5 years. I realized sitting in the audience that I'm working with the maybe 13 years and still I have a lot of fun. And I couldn't imagine that I would be working with anything else and having that much fun, even obstacles on the way, but they just made me stronger believer in D. As we are getting closer to the end, let me sum up the benefits of the Arenas platform. Unfortunately, the format of this talk doesn't allow me to show you all the advantages the Arenas platform's approach brings to the table. So instead of providing proof, let me simply name a few of the benefits I've experienced firsthand in real-world projects. The first and foremost aspect is the visibility it brings to the level of the architecture, together with the flexibility to adapt the architecture. The Arenas platform opens up a whole new world of module lifecycle management, enabling seamless and manageable refactoring and upgrading. Testing functionality takes on a completely new perspective once you realize the well-defined input-output protocol or interface between modules and above all, a clearly defined acyclic control flow. Versioning and synchronization become also more powerful because you're not changing a line in a file, but you're modifying the structure of the program together with its source code. In the end, each commit represents a structural change, not just a single or a text diff. Arenas platform is production-proven work in progress, and I am now looking for the opportunities to further develop and prove useful extensions to this idea. Looking ahead, some of the goals may include orchestrating a multitude of technologies into a single coherent solution, enabling multi-tenant cloud deployments and experimenting or exploring AI-assisted development using models trained on patterns. Beyond that, I have a vision I would like to achieve one day, to leverage the natural structure of trees and bring it into 3D space, ideally as an interactive holographic projection. A space where the way we develop software keeps pace with the way we think and is no longer inhibited or slowed down by awkward peripherals like keyboards, mice, and monitors. Well, to conclude, I'm not here to promote Python, but let me still finish with a piece of poetry. Arenas from thought to deed. D indeed for runtime speed. Code in D, it makes you fly. Arenas to scale up high. Arenas to chase the peak and go with D to make it sleek. Choose the D to tune the core. Arenas to ship much more. Well, this is my favorite slide of all, not only because the stress has now stepped back a bit, but above all because this is my opportunity to express my humble gratitude to all of you who have made it possible for me to pursue my dream to become and to remain a happy and efficient software creator. I enjoyed sharing this topic with you, and I hope this presentation was not only enjoyable but also useful, professionally interesting, and maybe even inspiring for you. I really hope you enjoyed listening just as much. Thank you very much for everything you have done. Thank you, Walter, and everyone else. Although the idea behind the Arenas platform is quite simple at its core, its abstractions usually require plenty of examples, explanations, and hands-on practice before learners experience the aha effect. I'm more than happy to present these concepts in greater detail now, tomorrow, or any time in the future. But for now, if you have any question, please raise your hand and maybe we'll both learn something new.
Put your hands together first.
You mentioned the garbage collector earlier, so I was wondering if you tried the new garbage collector.
No, not yet.
Sorry. Well, then I suggest.
What does it mean, a new?
So
in terms of time, I mean.
Yeah, sure. Steve over here and Amohiro, a new garbage collector for.
I learned about it just a couple of minutes ago.
So just trying it out because it's better.
Okay. The problem is not that I would have, or it would have an impact on the performance, but the memory footprint is like.
It does both.
Okay. Okay, I understand. Yeah.
Just a slight follow-up on that. If you do try the new garbage collector, we have seen like 50% reduction in memory on our large memory hogs. And if you try it and you find that it's still not fixing it, I have solved a few of those already at Symmetry, and they are hard to find, but once you find them, you're like, aha, now I understand why this is happening. And yes, sometimes it is between the keyboard.
Okay. To be completely honest, I didn't pay that much attention to fix the problem because it takes some time before I get I run out of the RAM. But there are also some specific points in the graph where I obviously accessed the IDE. which materialize all the stuff, all the trees in order to manipulate it and resave it, so the application gets updated in runtime. And this needs a lot of memory, so I like considering splitting these two processes, to get the effective view on the actual runtime interpreting without these interventions that cause or require that much memory by themselves. Yes.
And kind of a follow-up question, but you have your code and then your visualization on the IDE. Is there a way to take an existing application and kind of convert it into this, or do you have to start out with building your application with the less language and then go from there?
Is the question that is there a way how to convert an existing application to use this approach?
Right.
In the end, what this enables is not something that could not be written in plain D. Yes, these are higher level abstractions like what is C++ or object-oriented on the functional paradigm or to the functional paradigm. So this is another level of constructing the relations between modules so that the control flow stays acyclic. I would say it depends on what the actual architecture of the solution is. But this approach enables to build the solution from the top. So I can define what are the layers I can make use of in the solution, and how do I each layer decompose to various components, and what these components would need for having as elements underneath them, so that I can make a proper level of reuse in this situation. So it depends on the actual architecture of the solution, what to do. Transforming it into this, there is one thing left for optimization in the future, and this is everything you have seen in the less code, I mean in terms of the operations. They can be translated into the code, and that can be compiled. So actually the runtime can just traverse the architecture, but the actual execution of the functions written in the less language that implement a particular functionality may be compiled in the end. But you then lose the possibility to adapt or modify the solution or the system on the fly in the runtime. Yeah. So, thank you.
Any more questions? One more.
Just a little comment. I just love the fact that the language where everything is made of trees is called les, which means forest.
Yes, in Slovak language it is also so, yes.
All right, I think we'll end the questions there, so thank you again. All right, we have, it looks like half an hour until the final talk of DConf 2025. So go and enjoy yourselves for a little bit. All right. We had a half-hour break. We still needed an extra 5 minutes. Sorry about that, guys, but we're good to go now. Murilo, returning talker. The description of this talk doesn't give me hope that there will be capybara, but I'm holding out hope. So take it away.
Hi, everybody. Thank you very much for receiving me here again this year. This year, I'll simply be talking about something I have been working on. It is still a prototype. It's not yet in its final version, so please forgive me if it looks a little bit ugly, if the design is not the best, because I have not yet finished the details. But I have simply been working on a new way to write code, and I have been developing the software using, of course, the D programming language, a software which will later be used for other languages. It won't be used only for D, but it will be written in D. What does it mean to be a computer programmer? Many people think it is simply a matter of sitting and making a software work and then handing it over to whoever hired you. That's what many software developers do. But they skip the important parts. Many of them don't take the time to learn Boolean logic. They do not take the time to learn algorithm. They don't take the time to learn math. They don't take the time to learn assembly, machine code. They don't take the time to learn how compilers and interpreters work. They do not take the time to learn about graphs, about search, such as breadth first search. So they end up being those software developers which they know how to do something, but they have no idea how it works. And they end up making a computer software which is all bugged, always slow, which doesn't work well. So in order to be a real programmer, you have to take your time to study the math and the theory and the science behind it. You need to know how the computer works first. Okay, I know it is something difficult which takes years, but it is necessary to have this knowledge if you want to know the right way to write a computer software. Any idiot can write a computer software, but only a real programmer can do it in a way so it is fast, so it works everywhere, so it uses very little memory, and so it is also safe against attacks from hackers. Much of the software I see nowadays, it is either very slow, it keeps freezing on a cell phone, which should have 8 cores running at more than 3 gigahertz. And many of them have flaws which can be exploited by hackers because the people who coded that, they didn't really know what they were doing. They just kept copying things from ChatGPT, and they kept simply putting it all together, not having any idea what that was actually doing. That's what most software developers do. They simply build something without having any idea what they're doing. Why are programming languages so difficult? One big challenge is how do you write a code which is self-evident? Many people there come up with their own ideas. Some people try to add many, many comments to the code. Some people try to come up with conventions about how you name the variables. Some people try to break the code into modules, into several files. But nothing works. It is always difficult, and here is the reason why. First, before I get here, I just wanted to mention, they started with machine code, which was just purely binary, which was the first generation programming languages. Then they moved on to assembly, which was a second generation programming language. Then they moved on to Fortran, Pascal, COBOL, which were the third generation programming languages. And later they moved on to Python, C++, Java, which are the fourth generation programming languages. They are also the 5th generation programming languages, such as Prolog, but I think they were never very successful in the end. I have never seen anyone using them. But despite this whole evolution, they all continue to be extremely difficult to understand. I love this phrase: any idiot writes a code which can be understood by a machine, but only a good programmer writes a code which can be understood by another person. When you are typing code, you shouldn't be focused on how it works. You should be focused on how it looks when you read it. You should try to write a code which is the most readable, because the more readable it is, not only does it make it easier for you to refactor it later, but also if someone else comes after you, or if you want to share that code with the whole world and you want the world to see your project, to understand how it works. So that is the main challenge in the field of coding: how to make code something understandable. However, to create self-evident code is just as impossible as to create self-evident math. Here, take a look at this. This is something which is never self-evident. Even if you are a mathematician with a PhD, you can't simply look at it and automatically understand. You always have to take some time and burn some of your neurons staring at that thing in order to understand what is happening here, because it's so complex. Oh, here. And when it comes to programming languages, a programming language is math. Code is math. When you are typing code, you are simply performing a bunch of mathematical operations. After all, your computer is nothing more than a gigantic calculator. So code is math. And that is the reason why it is so difficult to make self-evident code. That's why programming languages are so difficult to be read by a human being, because code is math. It is to read a source code is just as difficult as to read this, because it is math. That's what it is. There was a man called Donald Knuth, who is the writer of that famous book called The Art of Computer Programming. He came up with a technique called literate programming. He even developed a software for it. It seems it didn't take off very much. I've never seen anyone use it, but he came up with an idea in order to help with that. The basic principle was, instead of typing the code and then placing comments to explain the code, you should type the comments first and then place the comments to be nothing, the code. I mean, you should type the comment first, and then you should place the code as being an extension of that comment. So it is as though you're typing just the comments of your software, and built into them, there will be the code. Okay, my coding style. When I am typing code, I try to follow certain rules. For example, here. Let's see if I find it. Here, found it. Downloads. No. Let me get an example here. Here, this is an example of a source code. I try to write everything I will add to the software, and each thing which I successfully implement, I check it in the box. Almost. There, I try to add one line of comment to everything I do in the code, and I try to keep everything very well indented. So you see it's very rich in comments. There is nearly a comment for every single line, and the indentations are very, very well respected. They are all kept exactly where they are supposed to be. And I try to name the variables very well. Each variable has a long, suggestive name. I try to follow this style in order to keep my code more readable. But despite that, it is still difficult. Nobody here can just look at it and immediately understand how it works. So my challenge is, how can I make it more and more readable? It can't get much better than this in text. So I thought, what if I can make it better than this with images? Here. Let me close this. There. Let me go back to the... thank you. Here. Is ChatGPT a solution? Of course not, and I'll tell you why. Because ChatGPT is very good at writing code, but it is not going to be the most, it's not going to be the most optimized nor the best code. Because ChatGPT is going to type the code based on everything it learned from the internet, and most of the code written on the internet is poorly written, which means ChatGPT tends to write code which is not as good as the code written by a professional computer programmer, which is why I don't even use. Okay? Oh, and there is more. You need to know how to talk to ChatGPT. If you do not explain it properly, it is not going to do it right. For example, if you simply say, give me the quick sort algorithm, if you do not write the algorithm needs to run in place, then it's going to give you a code with the wrong implementation, which keeps creating copies of the arrays, which is something which should not happen. So you need to know, you need to have a programmer with you to explain you how you're going to talk to ChatGPT in a way it will know how to make the code right. And that's why I think ChatGPT will not replace programmers, not for a while. Yeah, why text? We nowadays live in a world where everything is interactive. You can touch everything. So why do we stick to the text-based things? I was inspired by the Scratch software, which was created by MIT, and the concept of a flowchart here. I'm going to open the internet. Here, Scratch. In case somebody here doesn't know what a flowchart is, a flowchart is something like this, what you're seeing here. It is something widely used in order to demonstrate how an algorithm works. And it has some rules. Input-output has the shape of a parallelogram. The start is round. If it is an if statement, it has a shape of a rhombus. Other things, the normal statements, they are shaped like a rectangle, and so on. And here is the MIT. When I started to learn computer programming, I started with this. here. Explore. This programming language, it's actually just a toy, not a real programming language, but here, inside. Look how cool it is. You simply drag the colorful blocks of code and you connect them like pieces of Lego and you build your code like this. So inspired by that, I had the idea to do what I'm going to show you now. Okay, here is the demonstration. I want to remind everybody, in order to build this, I used the ARSD library made by that guy called Adam Roop, so I thank him for that. Okay, so here is a demonstration. I was developing and fixing some bugs while I was sitting here. So let me just compile the latest version here, which should be the best version so far. There, it worked, but oops, my computer doesn't have audio. Audio, okay. And here it goes. There. Here it is. I had decided to write here. This is the easiest software making software. It is a software for you to make software. Oh, unfortunately, it is not sound settings. Let me just change here HDMI there. Output. Why isn't the audio coming out? What is the audio? Well, anyway, unfortunately, the audio did not come out. There is a music here, and there are some sounds too. Let me see if I may unplug and replug it to see if it works. Ah, now you work. Okay, here it is. There are the settings, so you can set up the styles and the colors at will. Okay, so it's not too loud. You can switch off the music. You can see instructions. You can load a project which already exists. Or you can start a new project. Here is the new project. Take a look at this interface. There are 8 slots for actions. Each action would be equivalent to a line of code. And you can create a group of actions. And down here is all the information of this project, all the data. It's all here. And here you can have multiple tabs open at the same time. So you can have here. You can close one. I'm going to close just one, or you can close all. Now, wait a minute. Which one did I pick? Oh, what the fuck? There's a mouse here. Here, close project. Close only this one here. And we can mute the music too, and the sounds. Or do people prefer with the music and the sounds? Sounds, okay. Okay, so here. Okay, let's start to make here, let's make the code, which will be a software to make a Metal Slug game. There was an arcade game called Metal Slug many years ago. Here, we can create a new one and we can select if it is a statement, IO, condition, or a loop. In this case, it's going to be a statement. So I can type here description. I can say, let's suppose it would be easier for me to do that if I already have the source code here, so I can just transform, so I can just cheat by checking the source code to see what it is I should write next, because I have here with me here Metal Slug. I already have it all here, so I have here the source code. So I'm just gonna open it, just so I can check where I am in order to be making it. So the first thing I need to do, I need to import all the tools, right? So here, import the audio tools. So I type, this is the comment of the code, import all tools we need. And here is the source code, import multimedia. Here, import, it is audio output thread, okay? Forgive me if I'm being slow, but I cannot see it here in my screen. I can only see it here, so it's being difficult for me to do it like this. But we'll get there. Okay, then confirm, and now I have created the first section. Now the second action. It's gonna be a statement 2 here. Import the display. The display tools. Here's the module. No comment here, just type the source code. Display image key. Multimedia. Image key, key event point screen painter, simple window, and the sprite. Okay, I'll confirm. Let me just check here. Oh, I forgot to add here. You can edit, delete, or add the news here. Move, copy, do everything. So let's just edit this one here, because it was multimedia.audio. Confirm. Now the next one here, multimedia.image. No comment here. There. Now the two last one. Just one more action, one more statement. Tools. It's gonna be algorithm remove. Okay. There. Now the very last, which is the conversion, okay? version. Oh. Tools. There. Okay. Now I am finished with this. Now that I have all this, I could very well just turn this into an action group. So I can go here, then I select from here to here, then I'm gonna give it a group. I'm gonna give it import statements, a description. Here I import all the tools I will need. Create. And here it is. I can enter to check it out if I want, and I can edit everything inside too if I want. Okay, so now I have a whole group only to import the tools. Now let's start the main function, right? This is a statement. Okay. Here. Start the software, it starts at the main function. Comment. Source code. Void main. Like this. That's how it starts. Now I have to create this, okay? So in order to save time, I'm just gonna make it faster. I'm not gonna type the whole thing. So I'm here. Let's just create this point here. Create a point to be the origin. This point. Be drawn. Then I type here the code, which is cast a constraint. Okay. Confirm. Now create the images. Create some of the images. Image background here. Image background image. Entry screen image. Image. Intro screen image. And loop image. Loop image. Okay. Confirm. Now I have to create the window. The window. Here. Simple. New. It was 10.0.24 692. Oh, it was supposed to be metal slug, not solid slug. My mistake there. Okay. Okay, confirm. Now create the output thread. Play sounds. Thread. Now comes audio output thread. Sound. Thread. Put thread. True. Okay. I'm gonna skip now to the important parts, but all this here was used to create a variable. So here's what I'm gonna do. I'm gonna put a space on top just to separate them. Now I'm going to turn this into an action group. It's difficult to see here. There. Creating all variables. Here I create all the variables with the software we'll use. Create. Okay. Now moving on to this here. A loop. Let's make a loop here. It's a for each loop, okay. A loop. I can change the type if I want to. If I clicked on the right one, I can switch the types here. And I can also add an indentation to it, because I like to indent everything. So I could, for example, here in this group here, I could make sure everything is indented. I could add one more indentation to them. There, one. Confirm. There, one indentation to all of them. There. One here. It will be there. Now just one more and I'm finished with this. There. Okay, now they will all be indented in the source code. Now I can come here now create a loop. So here, I want to get all. I have already downloaded all of the frames and the sounds to make this video game. So I want to make all the sprites of the character running forward. So here. Comment. Forward. Now the source code for each index. Each index. Unit is 0, 8, going from 0 to 8. And here, 1. And this will have everything inside the main should have at least one indentation. Confirm. And now comes here. Have to create the image. I'll create first this image. here in the source code, loop image equals image from our image. I'll just stop here because that's enough. Oh, and of course I forgot to add one indentation to it. Yeah. Ah, this one's gonna have 2 indentations because it is inside the for each loop, right? So it has 2 indentations. And now just one more statement and this loop is over. Here. Create the sprite. Here. Should be this one here. Yeah, create the sprite, okay. Create the sprite. There, right here. Comment. Sprite and append it to the array. And here comes the source code. There. Running forward. And oops, okay, it uses this. It's appending it. So new sprite, and then sprite comes a window and the loop image. And because this one is the very last, this one is gonna have this now it's finished. Now I'll leave it without it, because this one is gonna have 2 indentations. And then I'll add here 1 just for the finish. Finish the loop. No comment, just type here this, which is gonna have only 1 indentation. Yeah. And now I can take, I'm going to separate it all. I'll put a new action in the middle, just separate it here. Add the new, and I can take, I can navigate, there is a map here, so I can navigate it. Now I can take all this and turn this into one group here. I'll turn all the way from here to here into another group. It's gonna be called create all running forward sprites. Then I add a description. Forward. Create. Okay, so I managed to go from all this, the text-based, which is very difficult. I want to go from here to here. So all I have here are these blocks, and each one of them tells me what it does. And if I click it, it shows me what is inside. Each one of them tell me what they do. And if I click inside, I can see even more and the details. Let's add just some more. Oh, I can, of course, I can just copy something here. I'll create a new one. Now I'll just do it like this, just add a new. Then I'll move it here. I'll move it here. And now let's just create a bunch of new, add a new. because I want people to see, you can paste something, you can copy paste. Like this. But I'll be adding new because I want people to see the map. The map allows you to navigate it. You can click in order to navigate the map. And if there are many actions, here, I'll just add a bunch of them so you guys can see the whole map. I should have left something prepared for it. I should have left a project all built with that so you guys could see it. But unfortunately, I couldn't do that. But here it is. I'm just gonna fill it up now. I won't delete it. You can save what you're doing. You can save it, you can give it a name. This is just a test, so I'm gonna save it. So it leaves it in a file where, no, let's say, here. It is in this file here, a binary file contains all the information, and then if I close it, if I close all, I can simply load it. Oops. I can just load it, test. I can just load it. There. And it is all there. Now I'm just gonna, I just want to create more because I want people to see the map once it is full of things. It shows what is above and what is below too. Almost there, just a few more. Just a few more and I'll get to where I want to go. Oops. Here, you can keep doing it here too. Add new, add new. Add new, add new, add new. Quick. Almost. Right, almost. Just a few more to show what I want people to see. Add a new. There, now it's beginning to show what I want people to see. The map, pay attention to the map. It shows here, it shows everything from the number 7 to the number 72, but it shows everything which doesn't fit. So there are another 6 new action buttons above this which don't fit. And if I go all the way up, then it shows me what is below. So oops, I'm sorry. It is being difficult for me to handle this mouse here, but what I wanted to show you people was the map. It is able to tell you not only everything which is up here, but also everything which is below or underneath it, in case you have a project which has hundreds of lines. That way, it's easy for you to navigate and to keep track of everything you're doing. And in the end, you can just create the source code here, and it creates here. Let's take a look at the source code. Where is it? Here, the source code. Here. Here is the source code. There are no comments here because I didn't add them. Here. Start with the main function. I ended up indenting this one. This one's supposed to be back. Only this one was supposed to be indented, my mistake. Here, the for each loop. Everything indented here the way I wanted it. And everything is very well described too. It has all the comments just like I wanted it to be. So it generated the source code just the way I was seeing in the flowchart diagram.
Yeah, well, we're actually out of time, so we're going to have to end
Okay.
the talk here. So
okay.
Thank you, Murilo.
Thank you.
Now, do we have any questions? One there.
So, Murilo.
Yes.
You've got a comment and a description. In this sort of literate programming thing, what's the difference, or why do you need two different sorts of things for descriptions and comments?
It is because, you see, sometimes if you are writing a line of code which does something extremely complex, you are going to need a very long explanation for that. You may need 4 or 5 lines just to explain, to be the comment of that line of code. The description, on the other hand, is meant to be just what appears here. When it comes to the description, what you want the description to be is, you want it to be just what a person reads here inside this small space. So the description is simply what appears outside that block. And if I want to know more, then I go inside, because when I create an action, you can see that the description is much smaller than the comment. Here, in the comment, I can type much more data than here. That is because the description is meant to be something short, merely to appear here. Whereas the comment itself can be something very large, where you elaborate further. This is the difference between a description and a comment. The description is just to be what appears here outside, whereas the comment can be a long description, a long explanation of what you're doing. Okay?
Great, thank you.
Okay, are there any more questions?
More a comment than a question, but I dabbled with literate programming 30-odd years ago when I first saw Knuth's web and tangle, well, his weave and tangle. I never used those ones. I used the C-web and C-tangle, and I found them really useful for typesetting maths, because it just typed the LaTeX code in and then print it all, and it was really useful to see the maths and then a bit of code to do it. But after that, I've just gravitated towards using something called NoWeb, which was basically the text part of it was more just markdown type comments. So I found it useful, but then I stopped using it, and now I just put comments in.
Okay. Thank you for your comment.
Cheers. Looking at the workflow, it seems to me that you're doing a lot of where you start with a piece of code and then you sort of split it up into this schema of your tool, and you have this separate file format for it. But looking at it, have you considered going the other way around, like having the code be the primary source of truth and formatting your code in such a way that your tool can pick up the structure from the code base automatically?
Yeah, I thought about that, about going the other way around. Yeah. In the future, it will be able to do that. It will be able to parse the code, understand what are the variables, each line of code, and then bring it. Of course, that is going to require people to follow the D language style when they are typing their code, because if you type your code in your own style, it may look strange after it has been converted. But I thought about that. There will be that in the future. Okay, no more questions. If there are no more questions, there is something I want to show before I get off the stage. Any more questions? Okay, then I'm just gonna show you what it is the Metal Slug game was supposed to be here. And you can even shoot. So this is what the game was supposed to be. Thank you all.
Thank you.
Thank you, everybody.
All right, and with the end of that, that is the end of the main program for DConf 2025. What was that? That's like our... we missed 2 years before Corona. Is this like our 10th actual in-person DConf, or is it the 11th? 11th. All right, so the 10th was last year. Okay, happy 11th anniversary, everyone. Okay. That's what you all think this year. Good? Amazing. Any other superlatives that you want to throw around? Amazing. Just amazing. It rocks. Amazing, amazing, it rocks. All right, I guess we can make a song out of that. Amazing, amazing, it rocks. Okay, so we are now at the point where you guys need to sit through the credits for the post-credits screen, and that's going to be the group photo. So the credits that we have here, as the usual thank yous, we do, of course, have... Oh, he's not even in the room right now, Walter, but Attila's here, so just pretend he's both of them. Our D-language overlords, you know, give it up for them. Without these people, we won't be here doing this. Yeah. I definitely want to give a shout out to Razvan over there for filling in for my busted voice a few times over the week, so give it up for him. Nicholas, he just ran downstairs to fetch some people, but he filled in very well for the loud Aussie role that I normally do to get you all upstairs. So see if you can get his attention from down there. Make some noise. You know, that would have been perfect timing if he ran up the stairs right then, but he didn't, so whatever. Who have we got here? Dennis was running mics for a bit, so is he downstairs too? No, you're over there. Okay. Yeah, just to make sure the people I want to thank are actually upstairs. But these people appear to be not here, I don't believe, from Symmetry, our sponsors. Mike wants to give a shout out to Nicholas Savage and Patrick Chemis for working with us to organise the conference. They make communication between Symmetry and the D-Language Foundation easy. Our other sponsors this time, Weka. Sorry, I might mangle your name here, Eyal. Is that how it's pronounced? Close enough. You've got to thank here for your help in arranging Weka sponsorship, and Tali Vashti for organising the Weka Happy Hour. So, yeah, I know we all enjoyed the Happy Hour. DConf. Yeah, Nicholas, you missed it. We were thanking you for being the loud Aussie. Yeah. Now, we have the absolute units up the back there, the AV team. Every year, they make this conference run smoothly. I don't even have to think about it. These guys are just professionals. We've got Patty, Harry, Canyon, and Tim. So give them a huge round of applause. This year's catering was provided to us by Easy Gourmet, so... And then we've got the Bright Space people, Sarah, Eden, and Tabby, for all their work in organising the conference and ensures it runs smoothly. And last, but very definitely not least, out the front, you've seen him, you've walked past him, our ever-vigilant laptop protector, Manip. Thank you, sir. Our laptops are safe. All right, and yeah, that's it on my thanks list. Does anybody want to thank themselves while we're here? We've got the attention of the internet. No? All right. Thank me. All right. Cool. Now that's the credits done. Get up here for the group photo, guys. We get taller people up the back, shorter people down the front. Yeah, you're a bunch of programmers. If you can't handle a sorting algorithm like that, I don't know what to do with you. I'll pop up the end there. All right, so we get a couple of decent photos, and then we'll do a stupid photo after we get like DConf or something. So let us know when you're good to go for the stupid one. Yeah, take a couple of normal ones. Yeah, three stupid ones. Crazy ones, you'll have DConf or something. Yeah, I guess that's a wrap.